Picture the curve of Earth as seen from space. Blue marble suspended in infinite darkness, wrapped in wisps of cloud that spiral and dance like brushstrokes on canvas. No sound reaches this vantage point, yet something profound whispers through the silence. A question that has haunted human minds since we first looked up at the stars. What if this world beneath us wasn't born from chaos? The morning sun breaks across the Himalayas, painting snow-capped peaks in shades of gold and rose. Rivers carve their ancient paths through valleys that have witnessed the rise and fall of civilizations. Forests breathe in rhythm with invisible tides, while deep beneath the surface, molten rock pulses like a planetary heartbeat. Every element moves in harmony, every system connected to the next in an intricate web of cause and effect. Science tells us this beauty emerged from cosmic accident. Gravity pulled dust into planets. Chemistry sparked the first molecules of life. Evolution sculpted complexity from simplicity across billions of years. Random processes, they say, gave birth to order. Yet standing at the edge of the Grand Canyon, watching light play across layers of stone that chronicle deep time, another possibility whispers through the wind. What if the accidents were too perfect? What if the chemistry too elegant? What if this blue world spinning through space bears the fingerprints of intention? The question isn't new. Ancient civilizations gazed at the same stars and sensed design in the cosmos. Egyptian astronomers mapped celestial cycles with stunning precision. Mayan mathematicians calculated planetary orbits centuries before telescopes existed. Indigenous cultures across continents spoke of Earth as a carefully crafted gift from sky beings or cosmic architects. Modern science has revealed wonders the ancients never imagined. We now know that Earth orbits within a narrow zone where water remains liquid. We understand how the moon stabilizes our planet's wobble, how magnetic fields shield us from deadly radiation, how atmospheric gases maintain temperatures suitable for life. Each discovery adds another layer to the mystery, not because these facts are inexplicable, but because they seem almost impossibly coordinated. Consider the odds. If Earth were slightly closer to the sun, oceans would boil away. Slightly farther, and ice would lock the planet in permanent winter. If our atmosphere contained more oxygen, fires would rage uncontrollably. Less and complex life couldn't exist. The gravitational dance between Earth and Moon creates tides that may have helped life emerge from ancient seas, yet also prevents our planet from wobbling chaotically like Mars. Scientists call this the Goldilocks principle. Everything is just right for life. But what if Goldilocks wasn't stumbling through a random forest? What if someone had prepared that porridge, arranged that furniture, made that bed with perfect knowledge of who would arrive? The thought sends ripples through comfortable assumptions. If Earth was designed, by whom and why? The implications stretch beyond science into philosophy, religion, and humanity's deepest sense of purpose. Are we accidental tourists on a random rock, or invited guests in a carefully prepared home? This journey will take us from the quantum realm to galactic superclusters, from ancient myths to cutting-edge theories, from accepted facts to speculative possibilities that dance along the edges of imagination. We'll encounter odd phenomena that mainstream science struggles to explain, mysterious alignments that suggest hidden order, and small stories that hint at grander patterns woven throughout our world's history. Some paths will lead toward conventional explanations. Others will venture into territories where science meets mystery, where data points toward possibilities that challenge everything we think we know about our place in the cosmos. The destination isn't certainty, it's wonder. The goal isn't proof, it's the expansion of what we consider possible. As twilight settles across Earth's surface and the first stars emerge in darkening skies, that original question returns with new weight. What if this world was designed? What if we're living inside someone's masterpiece? What if the answer changes everything about who we are and why we're here? The inquiry begins now, beneath stars that may hold secrets older than worlds. above ground that may conceal purposes deeper than time itself. Dawn breaks differently across Earth's surface, gentle in some places, dramatic in others, yet always within boundaries that sustain life. From Arctic tundra to equatorial rainforests, temperature variations remain within a narrow range that allows liquid water to exist. This isn't accident, according to some observers. It's precision. Earth orbits the Sun at an average distance of 93 million miles, a measurement scientists call an astronomical unit. Move Earth 5% closer to our star, and surface temperatures would rise enough to trigger runaway greenhouse effects. Venus serves as a cautionary tale, with surface temperatures hot enough to melt lead beneath crushing atmospheric pressure. Shift Earth 5% farther out, and ice would begin claiming larger portions of the globe, potentially triggering another snowball Earth event like those that nearly sterilized our planet in the distant past. But distance alone doesn't explain Earth's hospitality to life. Our planet tilts at 23.5 degrees relative to its orbital plane, an angle that creates seasons as different hemispheres receive varying amounts of sunlight throughout the year. Without this tilt, temperature differences between equator and poles would create permanent wind patterns, turning vast regions into uninhabitable deserts. Too much tilt, and seasonal variations would become so extreme that life couldn't adapt fast enough to survive. The atmospheric composition reads like a recipe crafted by a master chef. 78% nitrogen provides stability. 21% oxygen enables complex metabolism without triggering constant combustion. Less than 1% consists of other gases, including carbon dioxide, enough to trap heat through the greenhouse effect, but not so much that temperatures spiral out of control. Water vapor dances through this mixture, carrying energy from oceans to continents, moderating temperatures, and delivering life-sustaining moisture to even distant inland regions. Beneath this atmospheric shield, Earth's magnetic field extends invisible protection throughout space. Generated by molten iron churning in our planet's core, this magnetic envelope deflects most harmful radiation from the Sun. Mars lost its magnetic field billions of years ago, and solar winds subsequently stripped away its atmosphere. Venus lacks significant magnetic protection, contributing to its hellish surface conditions. Earth as magnetic field not only protects existing life, but may have been essential for life's initial emergence and evolution. The rotation rate adds another layer of precision. Earth spins once every 24 hours fast enough to prevent extreme temperature differences between day and night sides, slow enough to avoid atmospheric disruption. Jupiter rotates every 10 hours, creating winds that reach hundreds of miles per hour. Venus rotates so slowly that its days last longer than its years, contributing to extreme temperature variations that make the planet uninhabitable. Plate tectonics, unique among rocky planets in our solar system, constantly recycles Earth's surface. Continental drift seems chaotic, yet this geological activity regulates global climate by controlling carbon dioxide levels through volcanic outgassing and rock weathering. Mountain building creates diverse habitats and weather patterns. Ocean basin formation allows for deep ocean circulation that distributes heat around the globe. Even Earth's size appears optimized for habitability. Larger planets retain thicker atmospheres and experience stronger gravity that might prevent complex life from developing. Smaller planets lose their atmospheres to space and lack sufficient gravity to maintain surface water. Earth's mass creates gravity strong enough to hold on to its atmosphere and oceans, yet gentle enough to allow diverse life forms to thrive. The chemical composition of Earth's crust provides another puzzle piece. Silicon and oxygen dominate, forming stable rocks and minerals. Iron concentrations remain sufficient to generate magnetic fields, but not so high as to create toxic environments. Radioactive elements exist in quantities that warm the planet's interior and drive geological processes, without creating lethal radiation levels on the surface. Water covers 71% of Earth's surface, a percentage that seems almost arbitrary until examined closely. Less water coverage would reduce climate moderation and limit habitat diversity. More would submerge all land masses, preventing the evolution of terrestrial life and the development of technology using civilizations. Mainstream astronomy attributes these conditions to selection bias. We observe a habitable planet because we evolved on one. Countless worlds exist with different characteristics, and only planets with suitable conditions develop observers to marvel at their habitability. Yet some researchers find this explanation unsatisfying when faced with the sheer number of variables that must align simultaneously. The alternative perspective suggests intention behind the precision, not necessarily divine intervention, but perhaps cosmic engineering by advanced civilizations, or natural processes guided by principles science hasn't yet discovered. If Earth was indeed positioned, tilted, sized, and composed with deliberate care, then our planet represents something far more significant than a random oasis in an indifferent universe. As night follows day across Earth's surface, temperatures moderate within ranges that keep water liquid and life viable. The atmospheric blanket retains just enough heat, while magnetic fields continue their invisible guardianship against cosmic threats. Every breath drawn by every living thing depends on this intricate balance, a harmony so precise that some observers can't help but wonder if someone somewhere composed this symphony of conditions with conscious intent. In the deepest trenches of Earth's oceans, where sunlight has never touched stone, water moves with purpose. It carries minerals from mountain peaks to ocean floors, transports heat from equatorial regions toward polar ice, and cradles the earliest forms of life in chemical embraces that have remained largely unchanged for billions of years. Water seems ordinary because it surrounds us, yet its properties border on the miraculous when examined closely. Most substances contract when they freeze. Water expands. This seemingly simple reversal has profound implications for life on Earth. When lakes and rivers freeze, ice forms on the surface, while liquid water beneath remains insulated, allowing aquatic life to survive winter months. If water behaved like other materials, ice would sink, and bodies of water would freeze solid from bottom to surface, creating barren landscapes across much of the planet. The molecular structure of water creates this unusual behavior. Two hydrogen atoms bond with one oxygen atom at an angle that gives water molecules polarity positive and negative regions that attract each other in liquid form, creating the hydrogen bonds responsible for water's unique properties. These same bonds require significant energy to break, explaining why water remains stable across the temperature ranges found on Earth's surface. Water's role as a universal solvent appears equally precise. Its molecular polarity allows it to dissolve more substances than any other common liquid, making it ideal for transporting nutrients within living organisms and facilitating chemical reactions necessary for life. Yet water doesn't dissolve everything. It leaves behind oils and other hydrophobic molecules that form cell membranes, the boundaries that make individual organisms possible. The specific heat capacity of water, its ability to absorb large amounts of energy before changing temperature moderates Earth's climate in ways that seem almost intentionally designed. Oceans store vast quantities of solar energy during warm periods and release that heat gradually, preventing extreme temperature fluctuations that might sterilize the planet. This thermal buffering operates on multiple scales, from global ocean currents that regulate planetary climate to the water content of living cells that maintain stable internal temperatures. Surface tension, another water property, enables countless biological processes. Water molecules cling to each other with sufficient strength to allow insects to walk on pond surfaces, trees to transport nutrients from roots to leaves through microscopic tubes, and cells to maintain their shape without rigid walls. This cohesive force appears calibrated, precisely strong enough to enable these phenomena, weak enough to avoid preventing necessary fluid movements. Water's transparency to visible light seems another fortunate accident until considered more deeply. If water absorbed light like most substances, photosynthesis would be impossible below the ocean surface, and complex ecosystems couldn't develop in aquatic environments. The specific wavelengths that penetrate water happen to match those most efficiently used by photosynthetic organisms, as if the optical properties of water were tuned to support life's energy needs. The density maximum of water at 4 degrees Celsius creates circulation patterns that distribute nutrients and oxygen throughout aquatic environments. Warmer and colder water both rise to the surface at different times, creating mixing that prevents stagnation and maintains the chemical balance necessary for aquatic life. This circulation also helps regulate global climate by transporting heat between different regions of the planet. Phase transitions of water between solid, liquid, and gas occur at temperatures commonly found on Earth's surface. This allows water to exist in all 3 states simultaneously in many environments, creating weather patterns, geological processes, and biological systems that depend on water's ability to change form. The energy required for these phase changes further moderates Earth's temperature by absorbing excess heat during evaporation and releasing energy during condensation. Ancient civilizations recognized water's sacred nature, often depicting it as the source of life or the medium through which divine forces operated. Modern chemistry explains water's properties through molecular structure and thermodynamics, yet the precision of these characteristics continues to inspire wonder. Every property of water appears fine-tuned to support the chemistry of life as we know it. The abundance of water on Earth adds another layer to the mystery. Current models suggest that much of our planet's water arrived through bombardment by comets and asteroids during the late heavy bombardment period, roughly 4 billion years ago. Yet the timing and quantity of this water delivery seem remarkably convenient, arriving after. Earth had cooled enough to retain liquid water, but early enough to influence the development of the earliest life forms. Some researchers propose that water's unique properties guided evolution toward carbon-based life, while others suggest that life developed specifically to exploit water's characteristics. A more speculative possibility considers whether water itself was somehow designed or modified to possess properties that would inevitably lead to the emergence of complex biological systems. The isotopic composition of Earth's water provides additional clues. The ratio of heavy water containing deuterium to regular water falls within narrow ranges that support biological processes. Different ratios might prevent protein folding, DNA replication, or cellular metabolism from functioning properly. This isotopic precision appears to be another requirement for habitability that Earth happens to meet. As morning mist rises from valleys and streams, carrying water molecules on journeys that may span continents and decades, the blueprint embedded within H2O continues its ancient work. Each drop contains the same molecular architecture that enabled the first cells to form, that lifts nutrients through redwood trees, that regulates global climate, and that flows through the blood vessels of every complex organism. Water's properties seem almost too perfect for coincidence, yet too fundamental for coincidence to be impossible. Whether water represents cosmic fortune or intentional design remains an open question, but the precision of its properties continues to shape every aspect of life on Earth, from the smallest biochemical reactions to the grandest atmospheric cycles that drive weather across the globe. In the vast architecture of our solar system, Earth occupies a position that astronomers call the habitable zone, a band of space where temperatures allow liquid water to exist on planetary surfaces. Too close to our star, and water boils away into space. Too distant, and it freezes into permanent ice. Earth orbits within this narrow region, maintaining conditions that have supported life for billions of years. The concept seems straightforward until examined in detail. The habitable zone isn't a fixed ring around the sun, but a complex region that shifts based on atmospheric composition, planetary size, orbital characteristics, and stellar evolution. Venus sits near the inner edge of our Sun's habitable zone, yet surface temperatures exceed 800 degrees Fahrenheit due to runaway greenhouse effects. Mars occupies the outer edge, but lost most of its atmosphere billions of years ago, leaving a cold, nearly airless world where liquid water can barely exist. Earth's position within this zone appears almost precisely calculated. Our planet receives approximately 1,361 watts of energy per square meter from the Sun, a value that has remained relatively stable throughout the period when complex life evolved. This solar constant provides enough energy to maintain global temperatures within ranges that support liquid water, but not so much that atmospheric water vapor creates overwhelming greenhouse effects. The habitable zone concept becomes more intriguing when extended beyond our solar system. Astronomers have discovered thousands of exoplanets orbiting other stars, yet finding worlds that occupy their star as habitable zone and possess other characteristics necessary for life proves remarkably challenging. Most known exoplanets are either gas giants like Jupiter, tidally locked worlds with permanent day and night sides, or planets orbiting unstable stars that vary dramatically in energy output. Red dwarf stars, which comprise roughly 75% of all stars in our galaxy, present particular challenges for habitability. Their habitable zones lie much closer to the star due to lower energy output. Planets in these zones would likely become tidally locked, with one hemisphere permanently facing the star and the other in eternal darkness. The stark temperature differences might create atmospheric circulation patterns that could either distribute heat effectively or strip away the atmosphere entirely. Our Sun represents a relatively rare class of stars, a G-type main sequence star with stable energy output and a long lifespan. More massive stars burn through their fuel quickly, potentially ending their lives before complex life could evolve on orbiting planets. Less massive stars might support life, but their habitable zones present the tidal locking problems mentioned earlier. The Sun's characteristics appear well suited for supporting long-term biological evolution. Earth's orbital characteristics add further precision to our habitable zone placement. Our planet follows an elliptical path that varies Earth's distance from the Sun by only about 3% throughout the year. This relatively circular orbit maintains stable temperatures year-round. Many exoplanets follow highly elliptical orbits that would create extreme seasonal variations incompatible with complex life. The gravitational influence of other planets in our solar system helps maintain Earth's stable orbit. Jupiter, often called the vacuum cleaner of the solar system, deflects many comets and asteroids that might otherwise bombard inner planets. Yet Jupiter's position also helps maintain Earth's orbital stability through gravitational interactions that prevent dramatic changes in our planet's path around the Sun. Earth's axial tilt creates seasonal variations that may have encouraged biological diversity and evolutionary adaptation. Without seasons, life might have remained relatively simple, lacking the environmental pressures that drove the development of complex behaviors, migration patterns, and physiological adaptations. The 23.5-degree tilt appears optimal enough to create meaningful seasonal changes without causing extreme temperature variations that might prevent life from adapting. The concept of a galactic habitable zone adds another layer of positioning requirements. Earth's location within the Milky Way galaxy places us in a region with sufficient heavy elements to form rocky planets, but far enough from the galactic center to avoid excessive radiation from neutron stars, black holes, and other high-energy phenomena. We also orbit at a distance where the galaxy's spiral arms don't expose us to dangerous radiation on a regular basis. Some researchers propose expanding the habitable zone concept to include other factors beyond temperature and liquid water. The continuously habitable zone considers stellar evolution regions where planets could maintain suitable conditions throughout the billions of years required for complex life to evolve. The extended habitable zone includes subsurface environments where liquid water might exist even on planets outside traditional temperature-based habitable zones. Mainstream astronomy attributes Earth's position to statistical inevitability. With billions of stars and planets in our galaxy alone, some worlds must randomly occupy suitable locations. Yet the precision required for long-term habitability extends far beyond simple positioning. The combination of stellar type, planetary characteristics, orbital dynamics, and galactic location creates a multidimensional space where habitable worlds may be far rarer than initial calculations suggested. Alternative perspectives consider whether Earth's position results from intentional placement rather than cosmic fortune. Ancient astronaut theories propose that advanced civilizations identified suitable locations and either relocated existing planets or constructed worlds in optimal positions. Less exotic explanations might involve natural selection operating on planetary scales, perhaps only solar systems, with certain characteristics survive long enough to develop complex life and technological civilizations. As Earth continues its ancient dance around the Sun, maintaining the precise distance that keeps our oceans liquid and our atmosphere stable, the question of intention versus accident remains open. Each sunrise brings energy calibrated to warm without burning. Each seasonal cycle maintains the environmental variations that shaped the evolution of life. And each year, our planet completes another revolution through the narrow band of space where worlds like ours can thrive. Whether this positioning represents the ultimate cosmic coincidence or evidence of purposeful design may depend on discoveries yet to come, other worlds in similar positions, or the absence thereof, throughout the galaxy and beyond. Above us each night, the moon pulls silently at Earth's waters, creating the rhythmic rise and fall of tides that have marked time since long before human calendars existed. This gravitational dance seems so natural that we rarely consider how extraordinary it is or how precarious life on Earth might be without our unusually large companion. Most planets lack moons entirely, or host small, captured asteroids that exert minimal influence on their parent worlds. Earth's moon is different. Relative to our planet's size, it represents the largest moon in the solar system. This proportion creates gravitational effects that fundamentally shape Earth's behavior as a world capable of supporting complex life. The moon's most obvious influence manifests in ocean tides. Twice daily, lunar gravity pulls seawater toward itself, creating high tides on the side of Earth facing the moon and low tides elsewhere. But tidal forces extend far beyond coastal waters. The solid Earth itself rises and falls by several inches in response to lunar gravity, while atmospheric tides create subtle pressure variations that influence weather patterns around the globe. These tidal effects may have played crucial roles in life's emergence and evolution. Tidal pools concentrate organic molecules and minerals in shallow water environments, where complex chemistry can occur more easily than in deep ocean settings. The regular cycle of wetting and drying might have encouraged the formation of cell membranes and the development of early metabolic processes. Some researchers propose that tidal rhythms provided the environmental pressures that drove life's transition from ocean to land. The moon's gravitational influence extends to Earth's rotational stability. Without our large companion, Earth would wobble chaotically like a spinning top, losing momentum. Computer simulations suggest that Earth's axial tilt might vary by as much as 85 degrees over geological timescales without lunar stabilization. Such extreme wobbling would create wild climate variations, ice ages, followed by scorching periods as different hemispheres alternately pointed toward and away from the sun. Instead, the moon keeps Earth's tilt stable within a narrow range, maintaining the seasonal patterns that have persisted throughout the period when complex life evolved. This stability allowed ice ages to follow predictable cycles driven by subtle orbital variations rather than chaotic axial wandering. Predictable climate patterns may have provided the evolutionary pressures that encouraged the development of intelligence and technology in species like humans. The moon's origin story adds intrigue to its protective role. Most planetary scientists accept the giant impact hypothesis, the idea that a Mars-sized object collided with early Earth, blasting debris into orbit that eventually coalesced into our moon. This catastrophic birth created not only our stabilizing companion, but also tilted Earth to its current 23.5-degree angle, and may have contributed to the formation of our large iron core that generates Earth's protective magnetic field. The timing of this impact appears remarkably fortunate. Too early, and the debris might have fallen back to Earth or escaped into space entirely. Too late, and the collision might have sterilized a planet where life was already developing. The impact occurred during the Hadean Eon, when Earth's surface was still molten and hostile to life, yet late enough to influence the planet's long-term characteristics in ways that would later prove beneficial for biological evolution. Mathematical precision emerges in the moon's apparent size as viewed from Earth. Although the moon is 400 times smaller than the sun, it sits roughly 400 times closer to Earth, making both objects appear nearly identical in size when viewed from our planet's surface. This cosmic coincidence enables total solar eclipses events where the moon precisely covers the sun's bright disk while allowing the sun's corona to become visible. Ancient civilizations attached profound significance to eclipses, often interpreting them as messages from gods or harbingers of important events. Modern astronomy recognizes eclipses as natural phenomena resulting from orbital mechanics. Yet the precise alignment required for total solar eclipses continues to inspire wonder. No other planet in our solar system experiences eclipses with such mathematical elegance. The moon is synchronous rotation, showing the same face toward Earth throughout its orbit results from tidal locking that occurred over millions of years. This creates the familiar pattern of lunar phases as different portions of the moon facing Earth become illuminated by sunlight. These phases provided humanity's first reliable calendar, marking months and seasons long before artificial timekeeping existed. Lunar influence extends to biological rhythms in ways science is only beginning to understand. Many marine species time their reproductive cycles to lunar phases, presumably to synchronize with tidal patterns that affect egg and larval survival. Some research suggests that human sleep patterns and other biological cycles retain subtle connections to lunar rhythms, evolutionary legacies from ancestors who lived more closely connected to natural cycles. The moon's gradual retreat from Earth adds temporal significance to its current role. Tidal friction slowly transfers Earth's rotational energy to the moon's orbit, causing our companion to spiral outward at approximately 1.5 inches per year. In the distant past, the moon was closer and Earth rotated faster, creating stronger tides and shorter days. In the far future, the moon will be too distant to create significant tidal effects or to stabilize Earth's rotation. This temporal window raises questions about timing and intention. Complex life evolved during the period when the moon's distance created optimal tidal effects without overwhelming them. Intelligent life developed while the moon remained close enough to provide rotational stability and solar eclipses that inspired astronomical observation. Are these synchronicities mere coincidence or evidence of cosmic timing that suggests purposeful arrangement? Some researchers propose that large moons may be essential for the development of complex life, making Earth-Moon systems relatively rare in the galaxy. Others suggest that the giant impact was itself an improbable event, the collision parameters required to create a stabilizing moon rather than destroy the planet entirely represent a narrow range of possibilities that might occur infrequently around other stars. As the moon rises each night, pulling at Earth's waters and stabilizing our planet's rotation, its silent influence continues shaping the world where life evolved and consciousness emerged. Whether this companion represents cosmic fortune or evidence of intentional design, its presence has been essential for Earth's development as a habitable world, and may continue to be necessary for humanity's long-term survival on our seemingly designed planet. Deep beneath the Appalachian Mountains, layers of stone tell stories older than continents. Limestone formed in ancient seas holds the fossilized remains of creatures that lived when Earth's landmasses were, arranged in completely different configurations. Granite intrusions mark where molten rock pushed upward through overlying layers, cooling slowly into crystalline monuments to geological violence. Each stratum represents chapters in Earth's biography, a record written in minerals and preserved across deep time. The surface of our planet bears no resemblance to its original form. Volcanic outgassing created the earliest atmosphere. Meteoric bombardment scarred and reshaped the landscape for hundreds of millions of years. Yet from this apparent chaos emerged the geological processes that would make complex life possible: mountain building, ocean formation, and the recycling of elements through rock cycles that continue today. Plate tectonics operates like a planetary circulatory system, constantly moving material between Earth's interior and surface. Oceanic plates form at mid-ocean ridges, where molten rock erupts from deep within the planet, then migrate across ocean basins before diving beneath continental margins in subduction zones. This recycling process regulates atmospheric composition by controlling volcanic outgassing and rock weathering mechanisms that maintain carbon dioxide levels within ranges compatible with life. The apparent randomness of geological activity conceals remarkable precision in its effects on habitability. Volcanic eruptions release gases that replenish the atmosphere, while also providing nutrients that fertilize soils and oceans. Mountain building creates diverse environments and weather patterns, yet also exposes rocks to weathering processes that remove excess carbon dioxide from the atmosphere. Continental drift breaks up supercontinents that might otherwise create extreme climates, while also bringing landmasses together in configurations that enable species migration and evolution. Earth's internal heat engine drives these processes through radioactive decay of elements like uranium, thorium, and potassium within our planet's interior. The concentrations of these radioactive elements appear precisely calibrated enough to maintain active geology for billions of years, but not so much as to create lethal radiation levels at the surface. This heat source enables plate tectonics, magnetic field generation, and volcanic activity that have been essential for maintaining Earth's habitability. The formation of continents themselves represents a geological mystery with implications for life's development. Early Earth likely resembled a water world with few or no large landmasses above sea level. The process by which low-density crustal material accumulated into stable continents required specific conditions and timing that may not occur on all rocky planets. Without continents, Earth would lack the environmental diversity necessary for complex evolution. Mineral formation within Earth's crust follows patterns that seem almost deliberately organized for life's benefit. Iron ores concentrated in specific geological formations provide the raw materials necessary for both biological processes and technological development. Coal and oil deposits formed through biological activity then became preserved in geological formations where they would later prove accessible to intelligence that could exploit them. Rare earth elements essential for complex chemistry occur in concentrations sufficient for biological use without creating toxic environments. The water cycle interacts with geological processes in ways that maintain planetary habitability across geological timescales. Rainfall weathers rocks, carrying dissolved minerals to the oceans, where they provide nutrients for marine life. Ocean chemistry remains relatively stable despite constant inputs of various elements, because geological processes remove excess materials through sediment formation and seafloor subduction. This chemical buffering prevents oceans from becoming too acidic or basic to support life. Glaciation cycles, driven by orbital variations and continental positions, have periodically reshaped Earth's surface throughout geological history. These ice ages might seem destructive, yet they carved river valleys, formed fertile soils, and created environmental pressures that encouraged evolutionary adaptation. The timing and severity of glaciation events appear to have been sufficient to drive biological innovation without causing complete extinction of complex life. Mass extinction events punctuate Earth's geological record with episodes of apparent catastrophe. Asteroid impacts, massive volcanic eruptions, and climate shifts eliminated large percentages of species at various points in Earth's history. Yet each extinction event cleared ecological niches that enabled surviving species to diversify and evolve into new forms. The fossil record suggests that biodiversity generally recovered and exceeded pre-extinction levels after these catastrophic events. The Cambrian explosion represents one of geology's most intriguing chapters, a relatively brief period, roughly 540 million years ago, when complex life forms with hard shells and sophisticated body plans appeared suddenly in the fossil record. Various theories explain this biological revolution, yet the timing coincides with geological events, including rising oxygen levels, changing ocean chemistry, and continental configurations that may have created optimal conditions for evolutionary innovation. Geological timescales dwarf human history, yet the processes recorded in Earth's rocks operated within timelines that enabled complex life to evolve. If geological activity had proceeded faster, environmental conditions might have changed too rapidly for life to adapt. Slower geological processes might have failed to provide the environmental diversity and chemical cycling necessary for biological complexity to develop. Some researchers examine Earth's geological history and see evidence of fine-tuning processes calibrated to maintain habitability across billions of years through precise balances of volcanic activity, plate tectonics, and climate regulation. Others interpret the same evidence as demonstration of life as remarkable adaptability to whatever geological conditions happen to exist. Both perspectives acknowledge the intricate relationships between geological and biological processes that have shaped Earth's development as a living world. Ancient crystalline formations called zircons preserve chemical signatures from Earth's earliest history, suggesting that liquid water and possibly life-friendly conditions existed much earlier than previously thought. These mineral time capsules hint that Earth's geological systems established habitability relatively quickly after our planet's formation, another timing coincidence that either represents remarkable fortune or purposeful arrangement. As erosion continues carving new landscapes from ancient mountains, and volcanic activity builds new land from molten rock, the geological story of Earth continues writing itself in stone. Each earthquake shifts continental positions by microscopic amounts. Each volcanic eruption adds new material to the surface while releasing gases that influence global climate. The seemingly chaotic violence of geological processes maintains the precise conditions necessary for life through mechanisms that operate like clockwork across timescales beyond human comprehension. In the frozen vacuum of space, a creature no larger than a grain of sand drifts in hibernation. The tardigrade, or water bear, has survived temperatures near absolute zero, radiation levels that would kill most life forms, and the complete absence of air and water for more than a year. When returned to Earth and rehydrated, it awakens as if from sleep, resumes eating, and reproduces normally. This microscopic survivor embodies one of nature's most puzzling achievements: life as apparent preparation for environments that shouldn't exist on Earth. Tardigrades represent extremophiles, organisms that thrive in conditions once thought incompatible with life. Their existence raises profound questions about life's origins and purposes. Why would evolution craft survival mechanisms for space environments that terrestrial organisms would never naturally encounter? The traditional explanation suggests that extreme survival abilities evolved as responses to harsh but possible Earth conditions, volcanic environments, deep cold, intense radiation, or severe dehydration. Yet the precision of these adaptations extends far beyond what Earth's most extreme environments would require. Tardigrades survive radiation levels thousands of times higher than any natural source on Earth's surface. They endure pressure extremes from complete vacuum to crushing depths that exceed anything found in terrestrial environments. Their resurrection from complete dehydration seems almost supernatural until examined at the molecular level, where sophisticated protein structures prevent cellular damage during water loss and enable rapid recovery when moisture returns. Deep beneath ocean floors, where sunlight has never penetrated and pressure would crush surface life instantly, thriving ecosystems surround hydrothermal vents. These underwater oases host bacteria that derive energy from chemical reactions rather than photosynthesis, creating food webs that exist independently of solar energy. Tube worms, eyeless fish, and ghostly crabs populate landscapes that resemble alien worlds more than familiar Earth environments. The biochemistry of hydrothermal vent life operates through processes that seem engineered for extreme conditions. Chemosynthetic bacteria convert hydrogen sulfide and other chemicals into energy using metabolic pathways completely different from those employed by surface life. These organisms don't merely tolerate the crushing pressure, scalding temperatures, and toxic chemistry of deep-sea vents. They require these conditions for survival. Remove them to surface environments, and they quickly perish. The discovery of subsurface life extends the boundaries of Earth's biosphere, far beyond what was previously imagined. Microorganisms live in rock formations miles beneath the surface, metabolizing minerals and surviving on energy sources that have sustained them for millions of years. Some of these deep-dwelling creatures exist in environments with no connection to surface ecosystems, suggesting that life can establish itself in almost any environment where liquid water and energy sources exist. Seeds provide another category of remarkable survival stories. Lotus seeds recovered from dry lake beds have germinated after remaining dormant for over 1,000 years. Other plant species produce seeds capable of surviving decades or centuries, while maintaining the ability to sprout when conditions become favorable. This biological patience allows species to survive extended periods of environmental hostility while preserving genetic information across generations. The mechanisms that enable long-term seed survival read like biotechnology manuals. Protective coats prevent water loss and chemical degradation. Internal chemistry shifts into states that minimize molecular damage during extended storage. DNA repair mechanisms activate during germination to fix any genetic damage that occurred during dormancy. These adaptations appear almost deliberately designed to preserve life through difficult periods. Antarctic icefish produce antifreeze proteins that prevent ice crystal formation in their blood, allowing them to remain active in sub-zero temperatures that would kill other fish species. The molecular structure of these proteins demonstrates sophisticated chemistry that prevents water molecules from organizing into ice crystals. Similar antifreeze compounds appear in Arctic insects, high-altitude plants, and other organisms that regularly encounter freezing conditions. Desert pupfish survive in water so salty that it would quickly dehydrate most other organisms. Their kidneys concentrate waste products to levels that approach the limits of biological chemistry, while specialized gills exclude salt from their bloodstreams. Some populations live in water several times saltier than seawater, thriving in conditions that resemble the proposed environments of early Mars or Jupiter's moons. Bdelloid rotifers, microscopic freshwater animals, have reproduced without sex for millions of years, while maintaining genetic diversity through mechanisms that remain poorly understood. They survive desiccation by entering cryptobiosis, a state resembling death where all metabolic processes cease until water returns. During these dormant periods, they can survive freezing, boiling, radiation, and chemical exposure that would destroy most life forms. The precision required for cryptobiosis approaches the limits of what seems possible through undirected evolution. Organisms must protect every cellular component from damage during dehydration while maintaining the ability to restart all life processes when water becomes available. The molecular machinery involved includes specialized proteins, modified DNA structures, and cellular repair mechanisms that activate during resurrection. Magnetotactic bacteria contain internal compasses made of magnetite crystals that align with Earth's magnetic field, helping them navigate toward optimal environments. These biological magnets demonstrate precision engineering at the cellular level, crystal shapes and sizes. Optimized for magnetic sensitivity, cellular structures arranged to maximize directional accuracy, and behavioral programs that translate magnetic information into purposeful movement. The existence of extremophiles throughout Earth's environments suggests that life possesses an almost unlimited capacity for adaptation and survival. Yet the sophistication of these adaptations raises questions about whether such precise solutions to extreme challenges could arise through random processes alone. Each survival mechanism represents complex molecular engineering that appears optimized for specific environmental challenges. Some researchers propose that life's extreme survival abilities evolved in preparation for planetary catastrophes, mass extinctions, climate changes, or cosmic impacts that would test organisms' limits. Others suggest that extremophiles represent life's exploration of all possible niches, driven by competitive pressures to exploit unused resources. A more speculative possibility considers whether life itself was designed or guided to develop these remarkable survival capabilities for purposes that extend beyond Earth's current environment. As tardigrades continue drifting through space aboard human spacecraft, and chemosynthetic bacteria thrive in conditions that resemble early Earth or alien worlds, these micro-stories of survival hint at deeper mysteries about life's nature and purpose. Whether these adaptations represent evolutionary fortune, biological engineering, or evidence of design principles that extend beyond our current understanding, they demonstrate that life possesses capabilities that seem almost impossibly sophisticated for a process that supposedly operates through random variation and natural selection. Across the windswept plateau of Giza, stone monuments rise against the desert sky like geometric mountains crafted by forces beyond nature. The Great Pyramid aligns precisely with cardinal directions. Its passages point toward specific stars, and its mathematical proportions encode relationships that modern mathematics has only recently rediscovered. Yet according to conventional history, the civilization that built these structures possessed bronze tools, wooden levers, and rope technology that seems inadequate for achievements that challenge contemporary engineering capabilities. Ancient Egyptian texts describe their world as a carefully ordered creation, brought into existence through divine speech and geometric principles. Re sailed across the sky in his solar bark, following celestial paths that maintained cosmic order. Thoth measured and recorded the movements of heavenly bodies, establishing calendars and architectural alignments that would endure for millennia. To the Egyptians, Earth wasn't a random rock orbiting an arbitrary star. It was a sacred stage designed for the eternal drama of life, death, and rebirth. Halfway around the world, Mayan astronomers calculated planetary cycles with accuracy that would then be matched by European science, until the invention of advanced telescopes. Their long count calendar tracked time across thousands of years, predicting eclipses and planetary alignments with mathematical precision that suggests sophisticated understanding of celestial mechanics. Mayan creation myths describe multiple worlds destroyed and recreated by gods who fine-tuned each iteration until achieving a cosmos suitable for human existence. The Mayan concept of cyclical time differs fundamentally from linear Western chronology. Their calendars describe nested cycles within cycles, each governed by different celestial influences that shape earthly events. The current world represents the fifth creation in their cosmology. Previous versions were destroyed because they failed to produce beings capable of of proper worship and understanding. This suggests that Maya viewed Earth as habitability as the result of deliberate experimentation and refinement by cosmic architects. Sumerian texts, among humanity's oldest written records, describe the Anunnaki beings from the sky who shaped both Earth and humanity according to divine plans. These accounts detail terraforming activities, genetic modifications, and the establishment of human civilization under sky god guidance. While modern scholarship interprets these stories as mythology, alternative researchers note the sophisticated astronomical knowledge embedded within Sumerian literature and the precise correlations between their star maps and actual celestial mechanics. The Sumerian understanding of planetary cycles, stellar positions, and cosmic geography demonstrates knowledge that seems impossible for a civilization that supposedly developed astronomy without telescopes. Their descriptions of Nibiru, a planetary body with an elongated orbit through the solar system, match mathematical predictions for undiscovered objects in the outer solar system that contemporary astronomers continue seeking through advanced observation programs. Across the Pacific, Polynesian navigators crossed thousands of miles of open ocean using only star positions, wave patterns, and natural indicators to find tiny islands scattered across vast expanses of water. Their navigation techniques required generational knowledge of stellar movements, ocean currents, and weather patterns that enabled them to treat the Pacific Ocean like a familiar lake. These achievements suggest either remarkable observational abilities or inherited knowledge from sources with sophisticated understanding of Earth's systems. Hindu cosmology describes universe creation through precise mathematical principles, with cycles of creation and destruction spanning millions of years. The Vedic texts contain astronomical data about stellar distances, planetary periods, and cosmic architecture that align surprisingly well with modern scientific discoveries. These ancient sources describe Earth as one world among many, carefully positioned within cosmic structures that sustain life through deliberate arrangement rather than random chance. Aboriginal Dreamtime stories from Australia encode sophisticated astronomical information within narrative frameworks that have preserved accurate star maps and celestial event predictions across tens of thousands of years. These oral traditions describe the creation of landscape features, animal species, and natural laws through the activities of ancestral beings who shaped the world according to cosmic blueprints. The precision and longevity of astronomical knowledge embedded in Dreamtime stories suggests systematic observation and recording capabilities that challenge assumptions about prehistoric human intellectual capacity. Native American traditions throughout both continents describe Earth's creation through the deliberate actions of sky beings, star people, and cosmic architects who positioned the world within celestial frameworks designed to support life. Many tribes maintain detailed astronomical knowledge that enables accurate calendar keeping, agricultural timing, and ceremonial alignments with stellar events. Their creation stories consistently describe Earth as a carefully prepared home rather than an accidental habitat. The convergence of these independent traditions raises intriguing questions about humanity's earliest understanding of Earth's place in the cosmos. These civilizations, separated by continents and millennia, developed remarkably similar concepts. Earth as a designed world, sky beings as architects or gardeners, and human consciousness as the intended product of cosmic planning. The astronomical sophistication underlying many of these traditions suggests access to observational data or inherited knowledge that extends far beyond what conventional archaeology attributes to ancient peoples. Stone circles, temple alignments, and megalithic structures throughout the world demonstrate systematic astronomical observation, capabilities that required generations of precise measurement and mathematical analysis. Stonehenge tracks solar and lunar cycles with accuracy that enables eclipse prediction centuries in advance. Angkor Wat mirrors the constellation Draco as it appeared during its construction period. Nabta Playa in Egypt contains stone arrangements that map stellar positions from over 6,000 years ago. The builders of these monuments possessed mathematical and engineering knowledge that modern science struggles to replicate without advanced technology. Yet they created these structures during periods when conventional history suggests humans were just developing agriculture and basic metallurgy. Either our understanding of ancient capabilities is dramatically incomplete, or these civilizations had access to knowledge and assistance that mainstream archaeology hasn't recognized. The consistency of ancient testimony about Earth as designed nature becomes more significant when considering that these cultures had no contact with each other during the periods when their core beliefs developed. Independent development of similar ideas about cosmic architecture, celestial engineering, and intentional world creation suggests either universal human intuition about Earth as nature or inherited memories of actual events that shaped our planet as development. As contemporary science discovers the remarkable fine-tuning required for Earth's habitability, ancient wisdom traditions seem prophetic rather than primitive. Their descriptions of Earth as a carefully crafted world, positioned within cosmic structures designed to support consciousness, align with modern discoveries about planetary formation, stellar evolution, and the precise conditions necessary for complex life to develop and thrive. Invisible lines stretch across Earth's surface, connecting sacred sites that ancient builders somehow knew to align despite being separated by thousands of miles and centuries of time. From Stonehenge to Easter Island, from the pyramids of Giza to Machu Picchu, megalithic monuments mark points on a global pattern that suggests coordinated planning on a planetary scale. Modern researchers call these alignments ley lines, ancient roads, or Earth grid's geometric relationships that may reveal deeper truths about our world's architecture. The Great Pyramid of Giza sits at the geographic center of Earth's landmasses, positioned with mathematical precision that seems impossible for builders who supposedly lacked global maps or satellite perspective. Its base perimeter equals the circumference of a circle, whose radius matches the pyramid's height, encoding the relationship between pi and the geometry of Earth itself. The monument's orientation aligns with true north to within 3/60th of a degree, demonstrating surveying accuracy that challenges modern engineering capabilities. Extending lines from Giza through other ancient sites creates geometric patterns that span continents. A line drawn from Giza through Stonehenge continues to the precise center of the Nazca Lines in Peru. Another alignment connects Giza with Angkor Wat in Cambodia and Easter Island in the Pacific Ocean. These relationships suggest either remarkable coincidence or coordinated construction according to a global blueprint that ancient builders somehow accessed and implemented. Stonehenge demonstrates astronomical alignments with summer and winter solstices, lunar standstills, and stellar positions that required centuries of observation to establish. Yet the monument's design suggests its builders understood these celestial relationships from the beginning of construction rather than discovering them through trial and error. The site's location in southern England places it at optimal latitude for observing specific astronomical phenomena that would not be visible from other locations. The positioning of Stonehenge within Britain's landscape reveals additional layers of geometric precision. The site sits at the intersection of multiple ancient trackways that cross the island in straight lines, connecting other prehistoric monuments. These paths demonstrate knowledge of geographical relationships across distances that would require aerial perspective or sophisticated surveying techniques to establish accurately. Easter Island's massive stone statues gaze inland across the Pacific, yet their arrangement suggests awareness of the island's relationship to distant landmasses and astronomical phenomena. The statues align with solstice positions and stellar events, while their placement creates geometric patterns that mirror constellations visible from the island's latitude. The engineering required to carve, transport, and position these monuments challenges conventional understanding of Polynesian capabilities during the period when the statues were supposedly created. Machu Picchu clings to an Andean peak with architecture that demonstrates intimate knowledge of seismic engineering, astronomical alignments, and the precise geographical relationships necessary to position the site for optimal views of specific celestial events. The Intihuatana stone at the site's center casts shadows that track solar movements with calendar precision, while serving as an anchor point for alignments with other Andean sites hundreds of miles away. The Nazca lines in Peru create geometric patterns and stylized images that become coherent only when viewed from altitudes that ancient peoples could not achieve without flight technology. These ground drawings align with astronomical phenomena and connect to other South American sites through geometric relationships that span the continent. The precision required to create miles-long straight lines across varied terrain suggests surveying capabilities and planning coordination that challenges conventional archaeological interpretations. Angkor Wat in Cambodia mirrors the constellation Draco as it appeared during the temple's construction period, while its architecture encodes mathematical relationships that represent Hindu cosmological principles. The temple as orientation and proportions create a three-dimensional star map that connects earthly geography with celestial mechanics through stone engineering that required sophisticated astronomical knowledge and mathematical capabilities. Bekli Tepe in Turkey predates Stonehenge by thousands of years, yet demonstrates comparable astronomical knowledge and engineering sophistication. The site as circular stone arrangements track stellar positions and seasonal changes, while its massive pillars display carvings that suggest symbolic communication systems more sophisticated and typically attributed to hunter-gatherer cultures. The monument's deliberate burial around 8000 BCE raises questions about why advanced knowledge and capabilities were apparently abandoned or concealed. The global distribution of these sites follows patterns that suggest systematic placement according to geometric principles. Many monuments sit at intersection points of great circle routes that divide Earth's surface into geometric segments. Others mark positions where specific astronomical phenomena become observable or where geological features create unique electromagnetic conditions. The consistency of these relationships across different continents and time periods implies coordination that transcends individual cultures. Magnetic anomalies frequently occur near ancient sacred sites, suggesting that builders selected locations based on geological or electromagnetic properties that modern science has only recently begun to measure and understand. Some researchers propose that ancient peoples could detect these energy variations through biological sensitivity that contemporary humans have lost through technological dependence. Others suggest that the sites themselves were designed to interact with natural Earth energies in ways that enhance their astronomical or ceremonial functions. The mathematical relationships encoded within sacred site architecture often exceed the supposed knowledge of their builders. The Great Pyramid contains references to the speed of light, the precession of equinoxes, and Earth's circumference expressed through architectural proportions. Stonehenge demonstrates understanding of lunar cycles that require centuries of careful observation to establish. Angkor Wat incorporates mathematical constants and astronomical cycles into temple design with precision that rivals modern calculations. Ground-penetrating radar and satellite imagery continue revealing additional layers of geometric relationships between ancient sites. Buried structures, underground chambers, and foundation remains suggest that visible monuments represent only portions of larger construction projects that might extend across entire continents through underground connections or aligned surface features that have been obscured by time and natural processes. The implications of a global sacred site grid challenge fundamental assumptions about ancient human capabilities and coordination. Either prehistoric civilizations possessed knowledge, technology, and communication abilities far exceeding conventional estimates, or these monuments were constructed according to plans and principles provided by sources with global perspective and sophisticated understanding of Earth's geometric and astronomical relationships. As satellites map Earth's surface with increasing precision, and archaeologists discover new connections between ancient sites, the evidence for coordinated global construction, according to geometric principles, continues accumulating. Whether this coordination represents human achievement, inherited knowledge from earlier civilizations, or assistance from external sources remains an open question. Yet the mathematical precision and global scope of these relationships suggest that Earth's sacred sites may indeed mark points on a design grid that reveals deeper truths about our planet's architecture and purpose. Deep within Earth's atmosphere, electromagnetic pulses circle the globe at the speed of light, creating standing wave patterns between the planet's surface and the ionosphere. These Schumann resonances pulse at frequencies near 7.83 Hz, a rhythm that matches the alpha brainwave state associated with relaxation, creativity, and heightened awareness in human consciousness. This electromagnetic heartbeat of Earth has maintained its steady rhythm for millions of years, creating a frequency environment in which all terrestrial life evolved and developed. Lightning strikes around the world generate the electrical activity that drives Schumann resonances, with approximately 50 flashes per second, creating electromagnetic waves that propagate through the spherical cavity between Earth's conductive surface and the ionosphere. The primary resonance frequency depends on the circumference of Earth, a relationship so precise that changes in the resonance can indicate variations in global electromagnetic conditions or atmospheric chemistry. Modern research suggests that many biological processes synchronize with Earth's electromagnetic rhythms. Human brain waves, circadian cycles, and cellular activities show correlations with Schumann resonance patterns that hint at electromagnetic influences on consciousness and health. When humans are isolated from these natural frequencies in underground facilities or space environments, some experience disrupted sleep, impaired cognitive function, and other symptoms that improve when artificial Schumann resonance generators are introduced. The relationship between planetary electromagnetic activity and biological systems extends throughout the natural world. Migratory animals navigate using magnetic field variations that change predictably across Earth's surface. Marine mammals appear to communicate over vast distances using extremely low-frequency sounds that propagate through ocean water with minimal interference. Bird navigation systems respond to magnetic field variations that provide directional information more precise than any human technology. Earth's magnetic field itself creates a complex frequency environment through interactions with solar wind, cosmic radiation, and the planet's rotation. These electromagnetic phenomena generate ultra-low frequency signals that penetrate deep into the ocean and underground, creating communication channels that some researchers propose might influence geological processes, weather patterns, and biological systems in ways science is only beginning to understand. Mysterious hum phenomena reported worldwide may represent another aspect of Earth's electromagnetic communication. These persistent low-frequency sounds, typically between 30 to 80 Hz, are heard by sensitive individuals in locations spanning different continents and geological environments. Despite extensive investigation, the source of most hums remains unexplained, leading to speculation about whether they might represent natural planetary frequency, phenomena that some humans can perceive directly. The Taos hum in New Mexico, the Bristol hum in England, and similar phenomena reported in Australia, Canada, and other locations share characteristics that suggest common origins or generation mechanisms. These sounds typically occur in frequency ranges that correspond to natural electromagnetic phenomena, yet they appear to be heard rather than detected through normal electromagnetic sensing equipment. The selectivity of who can perceive these hums suggests that human sensitivity to Earth's frequency environment may vary significantly between individuals. Infrasound frequencies below the range of human hearing travels vast distances through Earth's atmosphere with minimal attenuation, creating a global communication network of natural signals generated by ocean waves, mountain winds, earthquakes, and volcanic activity. Animals demonstrate clear responses to infrasonic signals, suggesting that this frequency realm carries information that influences biological behavior on planetary scales. Some researchers propose that Earth's frequency environment was specifically tuned to support the development of consciousness. The Schumann resonance frequency matches brainwave patterns associated with meditative states, enhanced creativity, and expanded awareness. If consciousness represents the intended outcome of Earth's design, then electromagnetic conditions optimized for neural development and cognitive function might be evidence of purposeful environmental engineering. Ancient civilizations demonstrated sophisticated understanding of frequency phenomena through architectural acoustics, ceremonial practices, and technological applications that modern science struggles to replicate or explain. The Great Pyramid generates infrasonic frequencies when wind passes over its structure. Stone circles create acoustic effects that amplify specific sound frequencies while dampening others. Ancient temples worldwide incorporate design elements that optimize acoustic properties for enhanced human consciousness states. The relationship between sound, frequency, and human consciousness appears in spiritual traditions throughout history. Tibetan singing bowls, Aboriginal didgeridoos, Hindu mantras, and shamanic drumming all employ specific frequencies that correlate with altered states of consciousness and reported healing effects. These practices suggest that ancient peoples understood connections between frequency environments and human mental spiritual capabilities that contemporary science is rediscovering through neuroscience and bioelectromagnetics research. Crystalline structures within Earth's crust may function as natural frequency generators and transmitters, creating electromagnetic phenomena that influence surface conditions and biological systems. Quartz crystal formations demonstrate piezoelectric properties that convert mechanical stress into electrical signals. Large quartz deposits might generate electromagnetic fields that interact with atmospheric electricity, biological processes, and consciousness in ways that create optimal conditions for life and awareness development. The global electromagnetic field pattern created by Earth's rotation, magnetic field, and atmospheric electrical activity forms a complex standing wave system that some researchers compare to a planetary nervous system. This electromagnetic matrix carries information about solar activity, cosmic radiation, geological processes, and atmospheric conditions throughout Earth's environment with speed and precision that enable rapid global communication between distant regions of the planet. Modern technology increasingly interferes with Earth's natural frequency environment through radio transmissions, power line electromagnetic fields, wireless communication networks, and other artificial electromagnetic phenomena. Some researchers propose that this electromagnetic pollution might disrupt biological processes, navigation systems, and consciousness states that evolved in resonance with Earth's natural frequency patterns. The implications suggest that maintaining Earth as natural electromagnetic environment may be essential for long-term biological and psychological health. Satellite measurements reveal that Earth's electromagnetic field patterns demonstrate mathematical precision and geometric relationships that appear too organized for random natural processes alone. The global distribution of magnetic anomalies, electromagnetic field variations, and frequency phenomena creates patterns that some researchers interpret as evidence of engineered systems operating at planetary scales to maintain optimal conditions for life and consciousness development. As humanity develops increasingly sophisticated electromagnetic sensing capabilities, the complexity and precision of Earth's frequency environment becomes more apparent. Whether these electromagnetic phenomena represent fortunate coincidences that enabled consciousness to evolve, or evidence of intentional frequency engineering designed to support life and awareness, remains an open question that may determine how we understand our relationship with the planet that created us. Within the nucleus of every living cell, chains of DNA stretch like molecular libraries containing instructions for building and maintaining life. 4 chemical letters A, T, G, and C arrange themselves in sequences that encode the blueprints for proteins, regulate cellular processes, and guide the development of organisms from single cells into complex beings capable of consciousness and creativity. The precision of this genetic code rivals the most sophisticated computer programming languages ever devised by human intelligence. DNA stores information at densities that exceed any human technology. A single gram of DNA synthetically holds 215 petabytes of data equivalent to several million high-capacity hard drives compressed into a space smaller than a sugar cube. Yet this information storage system self-replicates, self-repairs, and adapts to environmental changes through mechanisms that demonstrate engineering sophistication beyond current human capabilities. The genetic code appears universal across all known life forms, from bacteria to whales, suggesting either common ancestry or adherence to a standardized programming language that governs biological information processing. This universality enables genetic material to transfer between different species, creating possibilities for horizontal gene transfer, genetic engineering, and evolutionary adaptations that seem to follow systematic rules rather than random processes. Error correction mechanisms within DNA replication systems exceed the reliability standards of human-designed computer systems. Multiple enzyme complexes proofread genetic information during copying, correct mistakes through sophisticated repair pathways, and maintain genetic integrity across millions of cellular divisions. The failure rate of DNA replication, approximately 1 error per billion base pairs, demonstrates precision that seems engineered rather than accidentally evolved. The existence of so-called junk DNA, genetic sequences that do and appear to code for proteins, once seemed to support random evolutionary processes. However, recent research reveals that much of this non-coding DNA serves regulatory functions, controls gene expression, and maintains chromosomal structure in ways that suggest systematic organization rather than accumulated genetic debris. Some of these sequences may represent dormant programming that activates under specific conditions or evolutionary pressures. Epigenetic modifications add another layer of complexity to genetic information processing. Chemical tags attached to DNA and associated proteins can alter gene expression without changing the underlying genetic sequence, creating heritable changes that respond to environmental conditions while maintaining genetic stability. These modifications suggest that organisms possess built-in adaptability programs that enable rapid responses to environmental challenges without relying solely on random mutations. The rapid appearance of complex biological innovations in the fossil record challenges gradualistic evolutionary models that depend on accumulation of small changes over extended periods. The Cambrian explosion represents the most dramatic example. Complex body plans, sophisticated sensory systems, and advanced ecological relationships appeared within a relatively brief geological time span. That seems insufficient for step-by-step evolutionary development through undirected processes alone. Molecular machines within cells demonstrate engineering principles that match or exceed human technological capabilities. ATP synthase generates cellular energy through rotary mechanisms that mirror human-designed turbines. Bacterial flagella employ rotary motors, drive shafts, and propeller systems that enable precise navigation and movement. DNA replication machinery includes helicase enzymes that unwind genetic material and polymerase complexes that copy information with extraordinary precision and speed. The complexity of protein folding presents mathematical challenges that suggest underlying organizational principles beyond random chemical interactions. Proteins must fold into specific three-dimensional shapes to function properly. Yet the astronomical number of possible configurations means that random folding would require more time than the unknown age of the universe to achieve correct results. Instead, proteins fold correctly within seconds, through processes that seem to follow predetermined pathways encoded within amino acid sequences. Convergent evolution, the independent development of similar features in unrelated species, occurs with frequency that some researchers find suspicious for purely random processes. Eyes, echolocation systems, flight mechanisms, and complex behaviors appear repeatedly across different evolutionary lineages in forms that suggest optimization according to engineering principles rather than chance variations shaped by natural selection alone. The information content required to specify complex organisms exceeds what random mutations could generate within available evolutionary timeframes, according to some mathematical analyses. Creating new functional genetic information appears to require directed processes rather than undirected variations, leading some researchers to propose that evolution operates through mechanisms that include systematic information generation rather than purely random variation. Symbiogenesis, the process by which separate organisms merge to create new biological entities, demonstrates coordination and integration that resembles planned merger activities rather than accidental associations. The incorporation of bacterial cells as mitochondria and chloroplasts within eukaryotic organisms required precise coordination of genetic systems, metabolic processes, and cellular structures that seems too complex for chance encounters to explain adequately. Developmental biology reveals that embryonic development follows precisely timed genetic programs that coordinate cellular division, differentiation, and tissue formation through cascading regulatory networks of extraordinary sophistication. These developmental sequences suggest that biological growth follows predetermined algorithms rather than emerging through random cellular activities guided only by environmental selection pressures. The existence of consciousness itself presents the ultimate challenge to purely materialistic evolutionary explanations. How does chemical activity in neural networks create subjective experience, creativity, abstract reasoning, and self-awareness? The gap between physical processes and conscious experience seems unbridgeable through gradual evolutionary development, suggesting that consciousness might represent a fundamental feature of reality rather than an emergent property of complex chemical reactions. Some researchers propose that life demonstrates signs of intelligent design through irreducible complexity biological systems that require multiple components to function and could undevelop through gradual addition of parts. Bacterial flagella, blood clotting cascades, and immune system recognition mechanisms represent examples of integrated systems that seem to require simultaneous development of multiple components rather than step-by-step evolutionary assembly. Alternative theories suggest that evolution operates through guided processes rather than purely random variation. These proposals range from quantum effects that bias mutations toward beneficial changes, to morphic fields that influence biological development, to periodic inputs from external intelligence that direct evolutionary development toward specific goals such as consciousness and technological capability. The debate between evolution and intelligent design may be resolvable through synthesis rather than conflict. Perhaps evolution represents the mechanism through which intelligence operates to create biological complexity and consciousness. Random variation provides raw material for selection processes, but directed influences guide development toward outcomes that serve larger purposes, such as creating beings capable of understanding and appreciating the universe that created them. As molecular biology reveals increasing levels of sophistication within living systems, the question of whether DNA represents evolved chemistry or programmed information becomes more significant for understanding humanity's origins and purpose. Whether genetic complexity arose through undirected natural processes or guided, development may determine how we interpret our role as conscious beings capable of deciphering and potentially modifying the code that created us. 66 million years ago, a mountain-sized asteroid traveling at cosmic velocity struck Earth's surface with the force of billions of nuclear weapons. The impact vaporized rock, ignited global wildfires, and shrouded the planet in debris that blocked sunlight for months. Yet from this apparent catastrophe came the evolutionary opportunity that eventually led to mammals diversifying, intelligence developing, and consciousness emerging in forms capable of contemplating their own origins. The Chicxulub impact represents one of 5 major mass extinction events that punctuate Earth's biological history, with episodes of devastating destruction followed by explosive evolutionary innovation. Each extinction cleared ecological niches occupied by dominant species, creating opportunities for previously marginalized organisms to diversify and develop new capabilities. Rather than representing evolutionary dead ends, these catastrophic events seem to function as reset mechanisms that accelerate biological innovation and complexity development. The Permian-Triassic extinction, the most severe die-off in Earth's history, eliminated over 90% of marine species and 70% of terrestrial organisms. Yet within a few million years, a brief moment in geological time life not only recovered but exceeded previous diversity levels, while developing new forms of complexity, including the first dinosaurs, early mammals, and sophisticated marine ecosystems that would dominate Earth for the next 250 million years. Volcanic catastrophes demonstrate similar patterns of destruction, followed by accelerated innovation. The Deccan Traps eruptions in India released massive quantities of lava and toxic gases that contributed to climate changes and extinction events. Yet the volcanic activity also created new land formations, altered ocean chemistry, and established environmental conditions that favored different evolutionary strategies. The seemingly destructive forces established foundations for subsequent biological developments. Ice ages represent cyclical catastrophes that have repeatedly reshaped Earth's surface and biological communities throughout the past several million years. Continental glaciation destroyed existing ecosystems across vast regions. Yet each glacial retreat revealed newly carved landscapes, fertile soils, and environmental opportunities that encouraged evolutionary adaptation and innovation. The timing and severity of ice ages appear calibrated to challenge life without completely destroying it. The role of catastrophes in human evolution seems particularly significant. Climate fluctuations in Africa during the past few million years created environmental pressures that may have encouraged bipedalism, tool use, brain expansion, and social cooperation in human ancestors. Rather than hindering human development, environmental instability apparently accelerated the evolutionary changes that distinguished humans from other primates and enabled technological civilization to develop. Asteroid and comet impacts throughout Earth's history delivered both destruction and innovation materials. These cosmic collisions brought water, organic compounds, and rare elements to Earth's surface, while simultaneously creating craters that became lakes, altered drainage patterns, and established geological formations that concentrated mineral resources. The timing of major impacts seems to coincide with evolutionary transitions that suggest catastrophic events may trigger biological innovation through multiple mechanisms. Supervolcanic eruptions create regional devastation that appears catastrophic from local perspectives. Yet these events also establish long-term environmental conditions that enable new forms of life to develop. The Yellowstone supervolcano system has erupted periodically throughout the past 2 million years, creating short-term devastation followed by enhanced soil fertility, altered climate patterns, and geological changes that increased habitat diversity across western North America. Ocean chemistry changes driven by volcanic activity, asteroid impacts, and climate variations have repeatedly altered the chemical environment available to marine life. These changes eliminated species adapted to previous conditions while creating opportunities for organisms with different metabolic capabilities to flourish. The chemical evolution of Earth's oceans appears to follow patterns that systematically expand the range of possible biological chemistry rather than randomly fluctuating around stable conditions. Solar activity variations create electromagnetic and radiation environment changes that influence atmospheric chemistry, climate patterns, and potentially biological mutation rates. Periods of increased solar radiation might accelerate evolutionary change through enhanced mutation frequencies, while decreased solar activity could create environmental pressures that favor different survival strategies. The timing of solar variations relative to biological evolution raises questions about whether cosmic cycles influence evolutionary development. Magnetic field reversals expose Earth's surface to increased cosmic radiation during transition periods when magnetic protection weakens. These events occur irregularly throughout geological history and may influence evolutionary development through increased mutation rates, climate changes, and atmospheric chemistry alterations. Some researchers propose that magnetic reversals create evolutionary bottlenecks that accelerate species change through enhanced environmental stress. The snowball Earth episodes during the Neoproterozoic era represent the most extreme climate catastrophes in Earth's history, with ice coverage extending to equatorial regions and ocean surfaces freezing to considerable depths. Yet these global ice ages preceded the development of complex multicellular life, suggesting that extreme environmental stress may be necessary for evolutionary innovations that enable new levels of biological complexity. Gamma-ray bursts from distant stellar explosions could periodically expose Earth to lethal radiation levels that cause mass extinctions while simultaneously delivering cosmic radiation that influences atmospheric chemistry and climate patterns. The frequency and intensity of these cosmic events might follow cycles that create regular evolutionary pressure while avoiding complete sterilization of Earth's biosphere. The mathematical precision of catastrophic timing throughout Earth's history suggests either remarkable fortune or systematic orchestration of environmental pressures designed to accelerate evolutionary development. The intervals between major extinction events appear long enough to allow biological complexity to develop, yet frequent enough to prevent evolutionary stagnation and encourage continued innovation and adaptation. Some researchers propose that catastrophes serve essential functions in biological evolution by breaking up stable ecological relationships that might otherwise prevent innovation. Stable environments favor existing species and discourage the development of new capabilities, while environmental disruption creates opportunities for previously impossible evolutionary experiments to succeed. Catastrophes might function as essential components of an evolutionary algorithm designed to generate increasing complexity and consciousness. The relationship between catastrophe and consciousness development seems particularly significant for understanding human origins and purpose. Major climate fluctuations preceded the development of human intelligence, tool use, language, and social cooperation. Environmental instability may have been necessary to encourage the evolutionary innovations that enabled humans to become conscious observers, capable of understanding their own origins and place in the cosmos. As contemporary science recognizes the essential role of catastrophes in driving evolutionary innovation, the apparent destructiveness of these events takes on different significance. Rather than representing random disasters that threaten life catastrophic, events may function as precisely timed catalysts that accelerate biological development toward consciousness and intelligence, suggesting that Earth's history of destruction and renewal follows patterns designed to create observers capable of appreciating the cosmic processes that created them. In the neural networks of a human brain, electrical impulses cascade through billions of synaptic connections, creating patterns of activity that somehow transform into the subjective experience of reading these words. This transformation from chemistry to consciousness represents perhaps the deepest mystery in science. How does matter arrange itself into mind? How do molecular processes create the inner universe of thoughts, emotions, dreams, and self-awareness that defines human existence? Neuroscience has mapped the brain with increasing precision, identifying regions responsible for memory, emotion, language, and sensory processing. Yet despite decades of research and technological advances that allow real-time observation of neural activity, the mechanism by which brain states become conscious experiences remains as mysterious as ever. The hard problem of consciousness explaining why there is subjective experience at all seems to resist solution through conventional materialistic approaches. The complexity of human brains suggests either remarkable evolutionary fortune or purposeful design toward consciousness as an intended outcome. 100 billion neurons form trillions of synaptic connections that create information processing capabilities exceeding any human-designed computer system. Yet this neural complexity emerged relatively recently in evolutionary history, during a period when environmental pressures didn't seem sufficient to explain the rapid development of such sophisticated cognitive capabilities. The relationship between brain size and intelligence across species reveals puzzling patterns that challenge simple evolutionary explanations. Humans possess brains that consume 20% of metabolic energy, despite representing only 2% of body weight and energetic cost that seems excessive unless consciousness provides survival advantages that outweigh the enormous metabolic investment required for neural complexity. Quantum effects within neural microtubules might provide mechanisms through which consciousness interfaces with physical reality in ways that transcend classical physics. Some researchers propose that quantum coherence within brain structures creates information processing capabilities that enable consciousness to influence physical events through mechanisms that conventional neuroscience cannot explain. These quantum consciousness theories suggest that awareness might represent a fundamental feature of reality rather than an emergent property of complex chemistry. The binding problem in neuroscience highlights the mystery of how distributed neural processes create unified conscious experiences. Visual perception, for example, involves separate processing of color, motion, shape, and depth information in different brain regions. Yet conscious experience presents a seamless visual field where all these elements integrate into coherent perceptions. The mechanism that binds separate neural processes into unified consciousness remains unexplained. Language capabilities in humans demonstrate cognitive sophistication that seems disconnected from environmental pressures that might have driven its evolution. The ability to create infinite expressions from finite grammatical rules, to communicate abstract concepts that have no physical reference, and to understand metaphors that connect disparate conceptual domains suggests mental capabilities that exceed immediate survival requirements by enormous margins. Mathematical abilities in humans reveal cognitive capacities that challenge evolutionary explanations based on adaptive advantage. The human ability to understand abstract mathematical relationships, to perceive mathematical beauty, and to discover mathematical principles that govern physical reality seems far beyond what would be required for survival in prehistoric environments. Yet mathematical thinking appears to be a natural human capability that emerges spontaneously in appropriate educational environments. Consciousness demonstrates non-local properties that suggest connections between individual minds and larger fields of information or awareness. Telepathic phenomena, collective unconscious effects, and morphic field influences appear in research literature, despite lacking acceptable theoretical frameworks within materialistic science. These anomalous consciousness effects hint that individual awareness might represent local manifestations of more fundamental consciousness, principles operating at cosmic scales. The fine-tuning of physical constants required for conscious observers to exist suggests either anthropic selection or intentional calibration of universal parameters to enable awareness to develop. If consciousness represents the purpose toward which cosmic evolution is directed, then the precise adjustment of physical laws to permit life and intelligence might be evidence of universal design principles that operate to create observers capable of understanding their own existence. Near-death experiences and altered states of consciousness provide phenomenological evidence that awareness might exist independently of normal brain activity. Reports of consciousness persisting during cardiac arrest under anesthesia and in other states where brain activity is minimal or undetectable suggest that consciousness might not be produced by neural activity, but rather transmitted or focused through brain structures that serve as receivers rather than generators. The historical development of human consciousness appears to follow patterns that suggest guided evolution toward specific cognitive and spiritual capabilities. Archaeological evidence indicates that symbolic thinking, artistic expression, and spiritual awareness emerged relatively suddenly in human history, creating cultural innovations that seem disconnected from immediate survival pressures, but aligned with developing capacities for abstract thought and transcendent experience. Children's cognitive development demonstrates innate capacities for language acquisition, mathematical thinking, and moral reasoning that seem too sophisticated to result from learning alone. The ease with which children master complex grammatical structures, mathematical relationships, and social concepts suggests that consciousness comes equipped with cognitive programs that guide development toward specific intellectual and ethical capabilities. Consciousness appears designed for understanding and appreciating the universe that created it. Human cognitive capabilities match the requirements for scientific investigation, mathematical analysis, artistic expression, and spiritual exploration in ways that suggest awareness was intended to comprehend cosmic principles and appreciate natural beauty. The alignment between human consciousness and cosmic complexity hints at purposeful design of both mind and universe toward mutual understanding. The emergence of collective consciousness through technological connectivity creates possibilities for enhanced awareness that might represent the next stage in consciousness evolution. Global communication networks enable information sharing and collective problem solving that transcend individual cognitive limitations while maintaining personal identity and creative autonomy. This technological augmentation of consciousness might fulfill intended purposes for aware beings within cosmic evolution. Some researchers propose that consciousness represents the universe becoming aware of itself through evolved observers. If cosmic evolution is directed toward self-understanding, then conscious beings serve as the means through which physical reality achieves self-awareness and self-appreciation. This perspective suggests that human consciousness represents a cosmic achievement rather than an accidental byproduct of biological evolution. As neuroscience continues investigating the neural correlates of consciousness while failing to explain consciousness itself, the possibility that awareness represents a fundamental feature of reality rather than an emergent property of matter gains credibility. Whether consciousness evolved accidentally through undirected, natural processes or developed according to cosmic design principles that guide universal evolution toward self-awareness may determine how humanity understands its role as conscious observers in an apparently conscious cosmos. The mystery of consciousness remains unsolved, yet its existence transforms the universe from a collection of unconscious matter into a reality capable of experiencing wonder, beauty, love, and understanding. Perhaps the emergence of awareness represents the most significant evidence that Earth and the cosmos were designed specifically to create conscious beings capable of appreciating the magnificent complexity and beauty of their cosmic home. Ancient Sumerian tablets speak of the Anunnaki beings from the sky who descended to Earth in the distant past and shaped both the planet's biosphere and humanity itself according to divine plans. These aren't merely creation myths to modern alternative researchers, but possible historical accounts of terraforming activities, genetic modifications, and technological interventions that established Earth as a deliberately designed habitat for intelligent life. The precision required for such planetary engineering suggests capabilities far beyond current human technology. Yet the consistency of similar accounts across independent cultures worldwide hints at memories of actual events rather than parallel mythological inventions. The Sumerian epic of creation describes how sky beings drained marshlands, redirected rivers, established agricultural systems, and modified existing life forms to create environments suitable for civilized society. These accounts detail engineering projects that would require advanced technology and comprehensive understanding of planetary systems, atmospheric chemistry, and biological processes. While mainstream archaeology interprets these stories as metaphorical, the technical sophistication embedded within the narratives suggests either remarkable imagination or inherited knowledge of actual terraforming activities. Hindu texts describe the Vishwakarma, cosmic architects who designed and constructed not only Earth, but entire universal structures according to mathematical principles that govern reality itself. These accounts include detailed descriptions of genetic modifications, consciousness transfers, and technological processes that enabled divine beings to create suitable vehicles for incarnation within physical reality. The precision of astronomical and mathematical information within these ancient sources suggests access to scientific knowledge that conventional history doesn't attribute to prehistoric civilizations. Native American traditions throughout both continents consistently describe star people who came from the sky to establish life on Earth and guide human development toward consciousness and spiritual awareness. These beings allegedly provided knowledge of agriculture, astronomy, medicine, and spiritual practices while maintaining ongoing relationships with human communities through visitations and communications that continued throughout history. The consistency of these accounts across tribes that had no contact during their cultural development suggests either universal human archetypes or inherited memories of actual extraterrestrial contact. The Aboriginal Dreamtime stories of Australia encode sophisticated astronomical information within narratives about ancestral beings who shaped landscapes, established natural laws, and created species according to cosmic blueprints that connected earthly geography with celestial mechanics. These oral traditions have preserved accurate star maps and astronomical predictions across tens of thousands of years while maintaining detailed knowledge of ecological relationships and geological processes that demonstrate scientific sophistication rivaling modern understanding. Ancient Egyptian texts describe interactions between humans and Neteru beings from the sky who established civilization, provided technological knowledge, and maintained ongoing oversight of human development through periodic incarnations and visitations. The precision of astronomical alignments in Egyptian monuments, the sophisticated understanding of mathematics and engineering demonstrated in pyramid construction, and the detailed knowledge of stellar cycles preserved in religious texts suggest either inherited technical knowledge or ongoing contact with technologically advanced beings. Mayan accounts describe visits from sky gods who provided calendrical knowledge, astronomical information, and technological capabilities that enabled the development of sophisticated civilization in Mesoamerica. The mathematical precision of Mayan calendars, the accuracy of their astronomical predictions, and the sophisticated engineering demonstrated in their monuments suggest access to scientific knowledge that seems impossible for isolated Stone Age civilizations to develop independently. Biblical accounts of encounters with angels, cherubim, and other heavenly beings describe interactions that demonstrate advanced technology, transportation capabilities, and knowledge that enabled these visitors to influence human development while maintaining distinct identities as non-human intelligences. The technical details embedded within biblical descriptions of divine encounters, when interpreted literally rather than symbolically, suggest technological capabilities that match or exceed contemporary human achievements in aerospace, energy systems, and information processing. The consistency of technological descriptions across independent ancient sources suggests either parallel cultural development of similar ideas or actual encounters with technologically advanced beings who possessed capabilities for interplanetary travel, genetic modification, and planetary engineering. These accounts consistently describe sky beings who shaped Earth's environment, modified existing life forms, and guided human evolution toward consciousness and technological capability. Modern UFO phenomena may represent continuation of ancient contact patterns, with contemporary witnesses reporting encounters that demonstrate technological capabilities similar to those described in historical accounts. The advanced propulsion systems, energy technologies, and apparent consciousness interface capabilities observed in modern UFO encounters suggest technological development that follows consistent principles across different time periods and cultural contexts. The genetic modifications described in ancient accounts align with modern discoveries about human DNA that suggest recent evolutionary changes inconsistent with gradual natural selection. The rapid development of human cognitive capabilities, the insertion of apparently non-terrestrial genetic sequences, and the presence of dormant genetic programs that activate under specific conditions hint at directed evolutionary modifications that might have been implemented by technologically advanced beings. Archaeological anomalies worldwide suggest technological capabilities and knowledge systems that exceed conventional estimates of ancient human achievements. Precision stone cutting, megalithic construction techniques, and sophisticated astronomical alignments demonstrate engineering capabilities that seem to require technological assistance or inherited knowledge from more advanced sources. The global distribution of these anomalous achievements suggests coordinated activities rather than independent parallel development. The Drake equation and Fermi paradox calculations suggest that intelligent life should be relatively common throughout the galaxy. Yet conventional science has found no evidence of extraterrestrial civilizations, despite decades of searching. Alternative researchers propose that evidence exists in ancient accounts, archaeological anomalies, and ongoing UFO phenomena, but mainstream science rejects this evidence due to materialistic assumptions that exclude possibilities of non-human intelligence interacting with human civilization. Some researchers propose that Earth represents a deliberately designed ecological experiment or consciousness development project managed by advanced civilizations with capabilities for interstellar travel and planetary engineering. This perspective suggests that human evolution toward technological civilization follows planned trajectories rather than random development, with periodic interventions that guide progress toward specific goals such as consciousness expansion and cosmic awareness. The anthropic principle in cosmology recognizes that universal physical constants appear fine-tuned to permit the development of conscious observers. Yet conventional science attributes this fine-tuning to selection bias or multiverse theories rather than considering intentional calibration by cosmic engineers. If advanced civilizations possess capabilities for universal engineering, then the apparent design of physical laws to enable consciousness development might represent evidence of cosmic-scale technological projects. Contemporary developments in genetic engineering, artificial intelligence, and space technology suggest trajectories toward capabilities that would enable advanced civilizations to implement the planetary engineering and consciousness development projects described in ancient accounts. As human technology approaches capabilities for genetic modification, atmospheric terraforming, and interplanetary travel, the technological requirements for creating designed worlds and guided evolution become comprehensible rather than impossible. The integration of ancient accounts, modern anomalous phenomena, and developing human technological capabilities suggests that Earth may indeed represent a designed world created and guided by advanced intelligences, with purposes that extend beyond random biological evolution. Whether these purposes involve consciousness development, cosmic awareness expansion, or preparation for galactic civilization membership remains speculative, yet the evidence for intentional design and ongoing guidance continues accumulating through archaeological discoveries, genetic research, and technological advancement that reveals the sophistication required for planetary engineering projects. Beneath the waves off the coast of Yanaguni, Japan, massive stone structures rise from the ocean floor in formations that seem too geometric for natural geology. Straight edges, right angles, and apparent stairways carved from solid rock suggest architectural construction that predates known human civilization by thousands of years, yet remains submerged since the last ice age, when sea levels were significantly lower. These underwater monuments challenge conventional timelines of human technological development, while hinting at sophisticated engineering capabilities in Earth's deep past. In the Carpathian Mountains of Romania, aluminum artifacts discovered in association with mastodon bones pose chronological puzzles that confound conventional archaeology. Aluminum requires advanced metallurgy and electrical processing techniques that weren't developed until the 19th century. Yet these objects appear in geological contexts suggesting ages of hundreds of thousands or millions of years. Similar out-of-place artifacts appear worldwide, consistently demonstrating technological sophistication that seems impossible for the time periods and geological contexts where they're found. The London hammer, discovered embedded in Cretaceous limestone in Texas, presents a metallurgical anomaly that challenges both geological and technological chronologies. The iron composition demonstrates purity levels impossible with medieval technology. Yet the hammer appears in rock formations, supposedly 140 million years old. X-ray analysis reveals internal structure consistent with advanced metallurgy, while the surrounding limestone shows no evidence of recent insertion or contamination. Ancient nuclear reactors in Gabon, Africa, operated naturally through uranium fission processes approximately 2 billion years ago, creating isotopic signatures identical to modern nuclear waste. While mainstream geology explains these natural reactors through coincidental geological conditions, some researchers note that the critical mass configurations and neutron moderation systems required for sustained fission seem too precise for accidental formation, suggesting possible ancient technological manipulation of geological processes. Microscopic metal spheres discovered in South African mines present manufacturing precision that exceeds contemporary capabilities despite appearing in rock formations billions of years old. These spheres demonstrate perfect balance, internal structure, and surface finish that suggests advanced machining techniques rather than natural formation processes. The spheres occur in quantity within specific geological layers, implying systematic production and distribution rather than random geological phenomena. The Antikythera mechanism, recovered from a Greek shipwreck, contains gear systems and astronomical calculations that match the sophistication of 18th century clockwork despite being constructed over 2,000 years ago. This bronze computer accurately predicted solar and lunar eclipses, tracked planetary positions, and calculated Olympic Games schedules through mechanical computations that demonstrate mathematical and engineering knowledge supposedly unavailable to ancient civilizations. Megalithic structures worldwide demonstrate construction techniques that modern engineering struggles to replicate without advanced technology. The precision fitting of massive stone blocks at Sacsayhuaman, the transportation and placement of multi-ton monoliths at Baalbek, and the acoustic properties designed into ancient temples suggest technological capabilities that exceed conventional estimates of prehistoric human achievement. The global distribution of these anomalous constructions implies coordinated knowledge systems rather than independent parallel development. Fossilized human footprints in geological layers predating accepted human evolution chronologies appear at multiple sites worldwide, consistently demonstrating modern human foot anatomy in contexts millions of years older than conventional human origins. These prints occur alongside dinosaur tracks in coal seams, and within rock formations that predate human evolution, according to standard paleontological timelines, suggesting either dramatic revision of human origins or preservation of evidence from unexplained time periods. The Baghdad Battery, consisting of clay jars containing copper cylinders and iron rods sealed with bitumen, generates electrical current when filled with acidic solutions. Dating to approximately 250 BCE, these devices demonstrate knowledge of electrochemical principles and practical electrical applications that were supposedly rediscovered until modern times. Similar electroplating artifacts appear in ancient contexts, suggesting systematic electrical technology rather than accidental discoveries. Precision-drilled holes in ancient granite and diorite artifacts demonstrate machining capabilities that require diamond-tipped or ultrasonic drilling techniques unavailable to Bronze Age civilizations. Core samples removed from these holes show spiral groove patterns consistent with high-speed rotary drilling, while the uniform dimensions and smooth surfaces suggest computer-controlled precision rather than hand-tool production methods. Ancient maps depicting Antarctica without ice coverage preserve geographical knowledge that shouldn't have been available until 20th century. Satellite mapping revealed the continent's actual topography beneath ice sheets thousands of meters thick. The Piri Reis map and other historical cartographic sources show coastlines and internal features that match modern surveys despite being drawn centuries before Antarctica was officially discovered. These maps suggest either ancient exploration capabilities or inherited knowledge from earlier civilizations with advanced geographical survey techniques. Anomalous isotopic ratios in ancient metal artifacts indicate smelting temperatures and atmospheric conditions different from those existing during their supposed periods of manufacture. Some ancient bronzes contain isotopic signatures suggesting production in environments with different oxygen levels or cosmic radiation exposure than currently exists on Earth's surface. These anomalies imply either dramatically different historical atmospheric conditions or manufacturing processes involving environmental controls unavailable to ancient technology. Microscopic technology embedded within ancient artifacts reveals manufacturing precision at scales invisible to naked eye inspection. Electron microscopy of ancient metal objects sometimes reveals internal structures, surface treatments, and compositional gradients that require atomic-level manufacturing control impossible without modern nanotechnology. These discoveries suggest either inheritance of advanced manufacturing techniques or production assistance from sources with sophisticated technological capabilities. Crystalline formations within ancient monuments demonstrate piezoelectric properties and acoustic resonance characteristics that suggest intentional engineering of electromagnetic and sonic effects rather than accidental architectural features. Some researchers propose that ancient builders deliberately incorporated crystal technology into stone constructions to create specific energy phenomena, consciousness-altering effects, or communication systems that modern science is only beginning to understand. Genetic anomalies in ancient human remains sometimes reveal DNA sequences that do not match expected evolutionary development or geographical distribution patterns. Some ancient specimens contain genetic markers suggesting rapid evolutionary changes, inserted genetic material, or population mixtures that seem inconsistent with gradual migration and adaptation models. These genetic puzzles hint at directed modifications or contact with genetically distinct populations during periods when such contact shouldn't have been possible according to conventional human history. The accumulation of these odd facts from deep time creates patterns that challenge conventional understanding of human technological development, geological chronologies, and the continuity of civilization. While individual anomalies might be explained through measurement errors, contamination, or misinterpretation, the collective weight of evidence suggests systematic gaps in mainstream historical and scientific understanding. These anomalies consistently point toward sophisticated knowledge systems, Advanced technologies and coordinated activities in Earth's deep past that may indicate either cyclical civilization development or intervention by non-human intelligences with advanced capabilities. Whether these ancient anomalies represent evidence of lost human civilizations, extraterrestrial contact, or natural phenomena beyond current scientific understanding, they demonstrate that Earth's history contains mysteries that conventional timelines and technological development models cannot adequately explain. The precision and sophistication revealed in these ancient artifacts suggest that intelligence and advanced technology have operated on Earth for far longer periods than mainstream science acknowledges, hinting at deeper truths about human origins and Earth's designed nature. The Amazon rainforest breathes with rhythmic precision, exhaling moisture during daylight hours and inhaling it back during the night, creating weather patterns that extend far beyond its borders and influence global atmospheric circulation. This vast green lung of Earth processes carbon dioxide and oxygen on scales that affect planetary climate, while its roots tap into underground networks that connect individual trees across thousands of square miles in communication systems of stunning complexity. Perhaps Earth itself functions as a living organism, with forests serving as organs, rivers as arteries, and the atmosphere as a planetary respiratory system. The Gaia hypothesis, proposed by scientist James Lovelock, suggests that Earth operates as a self-regulating system that maintains conditions suitable for life through feedback mechanisms involving the atmosphere, oceans, land surface, and living organisms. Rather than life adapting to planetary conditions, this theory proposes that life actively modifies Earth's environment to optimize its own survival, transforming our planet into a living entity that uses biological processes to maintain stability and homeostasis. Global temperature regulation demonstrates planetary-scale feedback systems that seem engineered to maintain habitability within narrow ranges suitable for complex life. When volcanic activity or solar variations threaten to alter global temperatures, biological and geological processes respond with changes that counteract these disturbances. Ice formation increases planetary reflectivity during warm periods, while greenhouse gas production by biological activity prevents runaway cooling during cold periods. These regulatory mechanisms operate with precision that resembles biological homeostasis rather than random geological processes. Ocean circulation patterns distribute heat, nutrients, and dissolved gases around the globe through currents that function like a planetary circulatory system. The Gulf Stream carries warm water from tropical regions toward polar areas, while cold water flows in the opposite direction, maintaining temperature gradients that moderate global climate and prevent extreme regional conditions that might make large areas uninhabitable. Similar circulation patterns in the Pacific, Indian, and other oceans create a globally integrated system that regulates planetary chemistry and climate. The carbon cycle demonstrates planetary metabolism through processes that convert atmospheric carbon dioxide into organic compounds through photosynthesis, store carbon in living organisms and geological formations, and return carbon to the atmosphere through respiration and decomposition. This global carbon management system maintains atmospheric composition within ranges that support life while preventing runaway greenhouse effects or carbon starvation that might destabilize planetary climate. Atmospheric composition remains remarkably stable despite constant inputs and outputs of various gases from biological processes, geological activity, and cosmic sources. Oxygen levels stay within narrow ranges that support complex life without creating conditions that would lead to constant combustion. Nitrogen concentrations provide atmospheric stability while remaining chemically inert enough to avoid toxic effects. This atmospheric management seems to operate through planetary-scale coordination of biological and geological processes. The water cycle functions as a planetary cooling and distribution system that transports energy from equatorial regions toward polar areas while maintaining global water availability for biological processes. Evaporation from ocean surfaces creates atmospheric moisture that falls as precipitation over land areas, supporting terrestrial life while returning to the oceans through river systems that transport dissolved minerals and nutrients to marine ecosystems. This hydrological circulation integrates atmospheric, oceanic, and terrestrial systems in ways that maintain planetary habitability. Magnetic field generation through Earth's molten core creates protective shielding that deflects harmful cosmic radiation while enabling beneficial solar energy to reach the surface. The strength and orientation of Earth's magnetic field appear calibrated to provide optimal protection for surface life while maintaining atmospheric chemistry and climate stability. Periodic magnetic field reversals create temporary vulnerabilities that might influence evolutionary development through increased cosmic radiation exposure. Plate tectonics operates like a planetary immune system that repairs surface damage through volcanic activity while recycling crustal materials to maintain optimal surface chemistry and geography. Continental drift prevents the formation of supercontinents that might create extreme climate conditions while ensuring adequate land-ocean distribution for biological diversity and climate moderation. Volcanic activity replenishes atmospheric gases while creating new land surfaces and soil fertility. Biological feedback mechanisms demonstrate planetary-scale coordination between different ecosystems and geographical regions that maintain global stability through seemingly intentional cooperation. Forest ecosystems produce moisture that supports agriculture in distant regions. Marine algae generate atmospheric gases that influence weather patterns over continents. Soil microorganisms process nutrients in ways that affect plant growth and atmospheric chemistry worldwide. The timing and coordination of global biological cycles suggests systematic management rather than random biological activity. Seasonal patterns coordinate plant growth, animal migration, and atmospheric chemistry changes across different continents and climate zones. Ocean productivity cycles synchronize with atmospheric circulation patterns and terrestrial growing seasons in ways that optimize global energy and nutrient distribution. Some researchers propose that Earth's biosphere demonstrates emergent intelligence through collective behavior of its component systems, rather than conscious awareness in individual organisms. This planetary intelligence might operate through information processing in biological networks, chemical communication systems, and electromagnetic phenomena that coordinate global responses to environmental challenges and opportunities. The resilience of Earth's biosphere to catastrophic disturbances demonstrates self-repair capabilities that seem almost intentional in their effectiveness. Recovery from mass extinction events follows patterns that restore biodiversity and ecological complexity within relatively brief geological time periods. Climate disruptions trigger biological and geological responses that eventually restore planetary stability through mechanisms that appear designed for recovery rather than accidental. Symbiotic relationships between different planetary systems create interdependencies that suggest coordination rather than independent operation. Atmospheric composition depends on biological activity, which depends on climate conditions, which depend on ocean circulation, which depends on geological processes, creating integrated feedback loops that maintain planetary habitability through systematic cooperation between different Earth systems. Contemporary environmental challenges test Earth's self-regulatory capabilities as human activities introduce disturbances that exceed the rate and scale of natural variations. Climate change, biodiversity loss, and chemical pollution create stresses that challenge planetary homeostasis while potentially triggering responses that might restore balance through mechanisms that could dramatically alter human civilization. The Gaia hypothesis suggests that Earth, as a parent design for life, reflects active biological engineering of planetary conditions rather than fortunate coincidence or divine intervention. If Earth functions as a living organism, Then human consciousness and technological capability might represent the planet's development of a nervous system capable of aware self-management rather than accidental evolutionary products. Some researchers extend the Gaia concept to propose that planetary consciousness emerges from the integration of all Earth's biological, geological, and atmospheric systems into a coordinated intelligence that actively maintains optimal conditions for continued evolution toward greater complexity and awareness. This planetary mind might use human technology and consciousness as tools for enhanced self-understanding and cosmic communication. As human activities increasingly influence global systems and space technology enables observation of Earth as an integrated entity, the question of whether our planet represents a random collection of geological and biological processes or a living being with self-regulatory intelligence becomes more significant for understanding humanity's relationship with the world that created and sustains us. Whether Earth was designed as a living system or evolved into one through biological processes, its remarkable stability and complexity suggest purposes that extend beyond random geological and evolutionary development. In the vast machinery of the solar system, planets trace their orbits with mathematical precision that has remained constant across billions of years. Earth completes its annual journey around the Sun in exactly 365.25 days, a fractional remainder so precise that human calendars require leap years to maintain synchronization with seasonal cycles. This orbital clockwork extends throughout the solar system, with each planet maintaining gravitational relationships that create stability, predictability, and harmonic resonances that suggest cosmic engineering rather than random gravitational accidents. Jupiter orbits the Sun in approximately 12 Earth years, creating a 12-to-1 resonance that stabilizes the inner solar system and protects Earth from asteroid bombardment while maintaining gravitational influences that keep our planet's orbit stable across geological time periods. This protective role seems almost deliberately designed. Jupiter as mass and position provide precisely the right gravitational influence to deflect dangerous objects while avoiding destruction of Earth's climate and habitability. The Moon's orbital relationship with Earth creates tidal forces that have remained within optimal ranges throughout the period when complex life evolved and consciousness developed. As tidal friction gradually increases the Moon's distance from Earth, the strength of tidal effects decreases at rates that have maintained beneficial influences on ocean circulation, biological rhythms, and rotational stability without becoming excessive or insufficient for supporting life's requirements. Solar eclipses demonstrate mathematical precision that seems impossibly coincidental for random celestial mechanics. The Sun's diameter exceeds the Moon's by a factor of 400, while the Sun's distance from Earth exceeds the Moon's distance by almost exactly the same factor. This creates apparent sizes that match so precisely that total solar eclipses reveal the Sun's corona while blocking its bright disk, providing optimal viewing conditions for observations that have advanced human understanding of stellar physics and solar system mechanics. Planetary resonances throughout the solar system create mathematical relationships between orbital periods that maintain long-term stability while preventing chaotic interactions that might destabilize planetary orbits. Jupiter and Saturn orbit in a near 2-to-5 resonance. Neptune and Pluto maintain a 3-to-2 resonance. And many smaller bodies follow orbital patterns that demonstrate harmonic relationships with major planets. These resonances suggest systematic organization rather than random gravitational outcomes. The inclination angles of planetary orbits remain within narrow ranges that prevent dramatic gravitational interactions while maintaining sufficient variation to create diverse environmental conditions throughout the solar system. Earth's orbital inclination relative to other planets minimizes gravitational perturbations while enabling asteroid and comet deflection through the gravitational influences of outer planets, particularly Jupiter's role as the solar system's vacuum cleaner. Rotational periods of planets. demonstrate relationships with their orbital characteristics that optimize various physical properties while maintaining system stability. Earth's 24-hour rotation period creates day-night cycles that moderate surface temperatures, prevent extreme atmospheric circulation, and provide circadian rhythms that coordinate biological processes with solar energy availability. The alignment between rotational and orbital periods throughout the solar system suggests coordinated timing rather than independent random development. The distribution of planetary masses follows patterns that create optimal gravitational architecture for supporting habitable conditions on Earth, while maintaining system-wide stability. The rocky inner planets provide solid surfaces and moderate gravitational fields suitable for complex life, while the massive outer planets create gravitational shields and orbital stability without overwhelming the inner system with tidal forces or radiation from captured high-energy particles. Asteroid belt positioning between Mars and Jupiter creates a reservoir of raw materials and small objects that occasionally provide meteorite delivery of rare elements to Earth while remaining sufficiently distant and dispersed to avoid constant bombardment that might prevent life from developing and maintaining complexity. The asteroid belt's location and composition seem precisely calibrated to provide benefits without creating excessive dangers. Cometary orbits bring water and organic compounds from the outer solar system to inner planets on schedules that appear timed to coincide with planetary development phases when these materials would be most beneficial for life's emergence and evolution. The frequency and timing of cometary impacts throughout Earth's history suggests systematic delivery of essential materials rather than random bombardment by cosmic debris. The solar system, as location within the Milky Way galaxy, provides additional layers of celestial clockwork that maintain optimal conditions for habitability and civilization development. Earth orbits the galactic center at a distance that provides sufficient heavy elements for rocky planet formation, while avoiding excessive radiation from neutron stars, black holes, and other high-energy phenomena that concentrate near the galactic core. Stellar evolution timetables demonstrate precise coordination between the Sun's energy output and Earth's biological development requirements. The Sun, as gradual increase in luminosity over billions of years, has been offset by atmospheric and biological changes that maintain global temperatures within habitable ranges. This solar planetary coordination suggests either remarkable coincidence or systematic calibration of stellar and planetary evolution processes. The precession of Earth's axis creates cycles that influence long-term climate patterns through changes in seasonal intensity and duration. Yet these variations occur within ranges that challenge biological adaptation without causing complete ecological collapse. Magnetic field interactions between planets, moons, and the Sun create electromagnetic environments that influence atmospheric retention, radiation protection, and potentially biological processes throughout the solar system. The coordination of these magnetic relationships suggests systematic electromagnetic engineering rather than random magnetic field generation through planetary core dynamics alone. The mathematical elegance of celestial mechanics enables accurate prediction of planetary positions, eclipse timing, and gravitational interactions across thousands of years using equations that describe precise relationships between mass, distance, and time. This mathematical predictability suggests underlying order and design principles rather than chaotic gravitational interactions that might be expected from random planetary formation processes. Contemporary space exploration reveals that the solar system's clockwork precision extends to smaller scales through the orbital mechanics of Moon's asteroid families and ring systems that demonstrate harmonic relationships, resonant periods, and gravitational coordination that create stability and predictability throughout the entire system. Each level of organization displays mathematical precision that suggests engineering rather than accident. Some researchers propose that the solar system represents an engineered environment designed to support the development of technological civilization through precisely calibrated gravitational, electromagnetic, and energy relationships that provide optimal conditions for life while maintaining long-term stability and predictability. The clockwork precision of celestial mechanics might reflect conscious design rather than fortunate cosmic coincidence. As human space technology enables increasingly precise measurement of planetary orbits, gravitational influences, and electromagnetic interactions throughout the solar system, the mathematical relationships and systematic coordination become more apparent and more difficult to explain through random formation processes alone. Whether this celestial clockwork represents the outcome of natural gravitational physics or evidence of cosmic engineering may depend on discovering similar precision in other stellar systems or recognizing design principles that operate at cosmic scales to create optimal conditions for consciousness development throughout the universe. In the creation mythology of ancient Egypt, Python speaks the world into existence through divine words that establish physical laws, create matter and energy, and design the relationships between celestial bodies that govern cosmic order. This creator god operates as a cosmic architect who plans universal structure before implementing creation through mathematical principles and geometric relationships that ensure stability, beauty, and purpose throughout all levels of reality, from atomic structures to galactic formations. Hindu traditions describe Vishwakarma, the divine architect of the universe, who designs and constructs not only Earth, but entire cosmic structures according to mathematical principles encoded in Sanskrit. Texts that demonstrate sophisticated understanding of astronomy, physics, and engineering. Vishwakarma creates through geometric forms called yantras that represent the mathematical relationships governing physical reality, suggesting that ancient peoples understood creation as an engineering project rather than random cosmic processes. The Aboriginal Dreamtime describes ancestral beings who travel across primordial landscapes, singing the world into existence through song lines that encode geographical, astronomical, and biological information within narrative frameworks that have preserved accurate knowledge for tens of thousands of years. These creator beings operate as cosmic surveyors who map relationships between earthly geography and celestial mechanics, while establishing the natural laws that govern ecological systems and human spiritual development. Greek mythology presents Prometheus as a divine being who shapes humanity and provides technological knowledge that enables civilization to develop beyond primitive survival, while other titans and Olympian gods establish the physical laws and cosmic structures that govern planetary and stellar mechanics. These mythological architects possess knowledge of fire, metallurgy, astronomy, and mathematics that they share with humans to guide civilization toward higher capabilities and cosmic understanding. Norse cosmology describes the Aesir gods as builders who construct Midgard, Earth, and other worlds within a cosmic framework called Yggdrasil, the world tree that connects different realms of existence through geometric relationships that govern the flow of energy, information, and consciousness throughout the universe. These divine architects establish not only physical structures, but also the laws of physics, time, and consciousness that enable intelligent life to develop and understand its cosmic context. Mesopotamian texts describe the Anunnaki as sky beings who arrive on Earth with advanced technology and knowledge that enables them to modify the planet's environment, create suitable conditions for life, and guide human development towards civilization through systematic interventions that include genetic modifications, technological transfers, and establishment of social systems that enable large-scale cooperation and cultural advancement. Native American traditions throughout both continents describe sky people, star nations, and cosmic ancestors who descend from celestial realms to establish life on Earth, provide sacred knowledge, and maintain ongoing relationships with human communities through visitations and spiritual communications that continue throughout history. These cosmic architects operate as gardeners and teachers who nurture human development while maintaining Earth as a carefully designed habitat for consciousness evolution. Aztec and Mayan cosmologies describe multiple creation cycles where cosmic architects repeatedly destroy and recreate the world until achieving optimal conditions for human consciousness to develop and flourish. These divine builders fine-tune planetary systems, atmospheric conditions, and biological processes through successive iterations that demonstrate systematic experimentation and refinement, rather than random cosmic processes or single-event creation. Pacific Islander traditions describe cosmic navigators who travel between star systems, establishing life on suitable planets and maintaining communication networks between different worlds through knowledge systems that encode astronomical information, navigation techniques, and cosmic geography within cultural practices and oral traditions that enable long-distance ocean travel and celestial observation without technological instruments. Chinese mythology presents Nuwa as a cosmic architect who repairs the damaged heavens through engineering projects that restore cosmic order and stability, while other divine beings establish the relationships between heaven, earth, and humanity that govern natural laws, social organization, and spiritual development. These cosmic engineers operate through mathematical principles and geometric relationships that create harmony and balance throughout all levels of existence. The consistency of cosmic architect themes across independent cultures suggests either universal human archetypes or inherited memories of actual encounters with beings who possessed advanced knowledge and capabilities for planetary engineering, genetic modification, and civilization development. The technical sophistication embedded within these mythological accounts often exceeds the supposed knowledge of the cultures that preserved them, suggesting either remarkable imagination or access to information from more advanced sources. Biblical accounts describe encounters with angels, cherubim, and other divine beings who demonstrate advanced technology, possess comprehensive knowledge of cosmic mechanics, and maintain ongoing involvement in human development through interventions that include environmental modifications, genetic influences, and provision of technological knowledge that enables civilization to advance toward greater capabilities for understanding and managing planetary systems. The Sumerian Enuma Elish describes cosmic architecture through battles between divine forces that establish physical laws, create celestial bodies, and organize universal structures according to mathematical principles that govern the relationships between matter, energy, space, and time. This creation epic encodes sophisticated astronomical knowledge and cosmological understanding that suggests either inherited scientific knowledge or contact with beings who understood cosmic engineering at levels that exceed current human capabilities. Modern UFO encounter accounts describe interactions with beings who demonstrate technological capabilities that match the advanced knowledge attributed to cosmic architects in ancient mythologies, suggesting either continuation of historical contact patterns or parallel development of similar technologies by different civilizations. These contemporary accounts often include descriptions of environmental modifications, genetic programs, and consciousness development activities that align with ancient descriptions of cosmic architect interventions. Some researchers propose that cosmic architect mythologies represent cultural memories of actual terraforming projects, genetic modification programs, and civilization development activities conducted by advanced extraterrestrial or interdimensional beings who possessed capabilities for interstellar travel, planetary engineering, and consciousness manipulation. This perspective suggests that Earth's apparent design reflects intentional construction, rather than random cosmic processes or divine miracles. The mathematical precision and astronomical knowledge embedded within cosmic architect mythologies demonstrates understanding of cosmic mechanics, planetary formation, and consciousness development that seems impossible for primitive cultures to develop independently, suggesting either inheritance of advanced scientific knowledge or ongoing contact with beings who possessed sophisticated understanding of universal engineering principles and cosmic architecture techniques. Archaeological evidence worldwide includes megalithic constructions, precision artifacts, and technological anomalies that suggest either lost human civilizations with advanced capabilities or assistance from external sources with sophisticated engineering knowledge. The global distribution of these anomalous achievements correlates with regions where cosmic architect mythologies describe ongoing interactions between humans and technologically advanced beings from celestial realms. As contemporary human technology approaches capabilities for genetic engineering, planetary terraforming, and interstellar travel, the technological requirements described in cosmic architect mythologies become comprehensible rather than impossible, suggesting that advanced civilizations throughout the galaxy might regularly engage in planetary engineering projects and consciousness development programs that create designed worlds and guided evolution toward technological civilization and cosmic awareness. Whether cosmic architect mythologies represent archetypal human imagination, inherited memories of historical events, or ongoing contact with advanced intelligences, these consistent cross-cultural accounts suggest that human consciousness recognizes Earth as a designed world created and guided by intelligence that operates at cosmic scales to establish optimal conditions for life, awareness, and technological development that enables consciousness to understand and appreciate the magnificent complexity of its cosmic environment. A shift of just 2 degrees in global average temperature could trigger feedback loops that transform Earth's climate system into conditions not seen for millions of years, potentially making vast regions uninhabitable and challenging the survival of complex life. The ice caps that reflect solar radiation back to space might melt completely, removing the cooling system that has helped regulate planetary temperature for geological ages. Ocean currents that distribute heat around the globe could shut down, creating regional climate extremes that would destabilize agricultural systems and ecosystem relationships throughout the world. The ozone layer that protects Earth's surface from lethal ultraviolet radiation measures only 3 millimeters thick when compressed to sea level pressure. Yet this thin shield enables complex life to exist on land and in shallow waters. Depletion of stratospheric ozone by human-produced chemicals demonstrated how quickly protective systems can degrade when subjected to chemical interference, threatening to expose terrestrial life to radiation levels that could cause widespread genetic damage and ecosystem collapse. Atmospheric oxygen concentrations that currently support complex life exist within narrow ranges where small changes could have catastrophic effects. Increase oxygen levels by just a few percentage points, and wildfires would rage uncontrollably across the globe, consuming forests and releasing massive quantities of carbon dioxide that would accelerate climate change. Decrease oxygen below current levels, and large animals would begin suffocating as metabolic demands exceed available oxygen supplies in the thinning atmosphere. The delicate balance of greenhouse gases maintains Earth's temperature within ranges suitable for liquid water and biological processes. Yet human activities are rapidly altering atmospheric composition in ways that could trigger irreversible changes. Carbon dioxide levels have increased by over 40% since the Industrial Revolution, while methane, nitrous oxide, and synthetic greenhouse gases continue accumulating at rates that may exceed the planet's ability to maintain climate stability through natural feedback mechanisms. Ocean chemistry changes through acidification and warming threaten marine ecosystems that form the foundation of global food webs and climate regulation systems. As seawater absorbs excess carbon dioxide from the atmosphere, chemical reactions create more acidic conditions that dissolve the shells and skeletons of marine organisms while disrupting the ocean's ability to support biodiversity and maintain its role in global climate control and atmospheric gas regulation. Biodiversity loss accelerates through habitat destruction, pollution, climate change, and invasive species introductions at rates that may constitute the sixth mass extinction in Earth's history. The intricate relationships between species that maintain ecosystem stability and resilience are being severed faster than new relationships can develop, potentially leading to widespread ecological collapse. That could undermine the biosphere's ability to support human civilization and complex life. Soil degradation and erosion threaten the thin layer of fertile earth that supports terrestrial plant growth and agricultural systems worldwide. Intensive agriculture, deforestation, and urbanization remove soil at rates thousands of times faster than natural soil formation processes, potentially eliminating the foundation for land-based ecosystems and food production systems within decades or centuries, rather than the millions of years required for soil renewal through geological processes. Freshwater resources face depletion and contamination that threatens both human civilization and natural ecosystems that depend on clean water for survival. Groundwater aquifers that took thousands of years to fill are being drained within decades, while surface water systems become increasingly polluted with industrial chemicals, agricultural runoff, and plastic waste that disrupts aquatic life and renders water supplies unusable for drinking and irrigation. The magnetic field that protects Earth from cosmic radiation shows signs of weakening and potential reversal that could expose surface life to increased radiation levels while disrupting navigation systems, communication networks, and electrical infrastructure that modern civilization depends upon for survival. During magnetic field reversals, Earth's protective shield weakens significantly, potentially allowing harmful solar and cosmic radiation to reach surface levels that could damage DNA and disrupt biological processes. Tectonic instability could trigger volcanic events or massive earthquakes that alter global climate conditions through dust and gas emissions that block sunlight or enhance greenhouse effects. Supervolcanic eruptions like those from the Yellowstone or Toba systems could inject sufficient material into the atmosphere to cause volcanic winters that would disrupt agriculture worldwide, while potentially triggering ice age conditions that could last for thousands of years. Asteroid or comet impacts represent ongoing threats that could cause immediate climate disruption and biological devastation, similar to the event that eliminated dinosaurs 66 million years ago. While large impacts are statistically rare, smaller objects regularly enter Earth's atmosphere and could cause regional devastation, while larger impactors could trigger global environmental changes that would challenge human civilization's survival and Earth's capacity to support complex life. Solar activity variations could disrupt Earth's climate and technological systems through increased radiation, electromagnetic interference, and atmospheric chemistry changes that alter the energy balance and habitability conditions that have remained relatively stable throughout human civilization. Extreme solar events could damage Earth's ozone layer, disrupt climate patterns, and destroy electronic infrastructure while exposing surface life to dangerous radiation levels. The interconnected nature of Earth's systems means that disruption in one area can cascade through other systems, amplifying environmental changes beyond what might be expected from individual impacts. Climate change affects ocean circulation, which influences weather patterns, which impact agriculture, which affects human societies, which respond through activities that may further destabilize environmental systems through feedback loops that could accelerate toward tipping points beyond human control. Contemporary environmental challenges test the limits of Earth's self-regulatory capabilities that have maintained habitability throughout geological time. The rate and scale of human-induced environmental changes may exceed the planet's ability to adjust through natural feedback mechanisms, potentially triggering rapid transitions to alternative stable states that might not support current biological diversity or human technological civilization. The precision required to maintain Earth's habitability suggests that apparent environmental stability may be more fragile than it appears from human historical perspectives. The narrow ranges of temperature, atmospheric composition, ocean chemistry, and other environmental variables that support complex life may represent a delicate balance that could shift rapidly if critical thresholds are exceeded through natural variations or human activities. Some researchers propose that Earth's environmental systems include built-in resilience mechanisms designed to recover from disturbances and maintain habitability even under stress, while others argue that the planet's apparent design for life includes vulnerability to catastrophic changes that could serve as evolutionary pressures or selection mechanisms that favor certain developmental directions over others. Whether Earth's environmental fragility represents inherent limitations of planetary systems or design features that maintain optimal evolutionary pressures for consciousness development remains an open question with profound implications for understanding humanity's relationship with the planet and our responsibilities as potentially the first species capable of understanding and potentially managing Earth's environmental systems on global scales. The current environmental crisis may represent a crucial test of whether human intelligence and technology can develop quickly enough to manage planetary systems effectively, or whether Earth's apparent design includes self-correcting mechanisms that will restore balance through processes that might dramatically alter human civilization while maintaining the planet as long-term habitability for continued consciousness evolution and cosmic awareness development. In laboratories around the world, scientists manipulate DNA sequences with precision that enables them to create organisms with capabilities that never existed in nature, while computer programmers develop artificial intelligences that demonstrate creativity, problem-solving abilities, and even artistic sensibilities that rival human creative capabilities. Humanity stands at the threshold of becoming cosmic architects ourselves, developing technologies that could enable us to design new forms of life, terraform other worlds, and potentially create planetary systems optimized for consciousness development across galactic distances. Genetic engineering technologies already enable scientists to modify existing organisms and create entirely new biological forms that serve specific purposes, such as producing medicines, cleaning environmental contamination, or generating energy through biological processes. CRISPR gene editing tools provide capabilities to rewrite DNA with accuracy that approaches the precision demonstrated in naturally occurring genetic systems, while synthetic biology techniques enable construction of completely artificial organisms designed according to human specifications and purposes. The development of artificial intelligence represents humanity as first steps toward creating consciousness and intelligence through technological means rather than biological evolution. Machine learning systems demonstrate capabilities for pattern recognition, creative problem-solving, and autonomous decision-making that suggest we may soon create digital minds that equal or exceed human cognitive abilities while possessing different types of consciousness and awareness that complement rather than replace human intelligence. Terraforming technologies under development could enable humans to modify planetary atmospheres, climates, and surface conditions to create habitable environments on worlds that currently cannot support Earth-based life. Proposals for transforming Mars include releasing greenhouse gases to thicken the atmosphere, introducing extremophile organisms to begin biological processes, and establishing self-sustaining ecosystems that could eventually support human civilization without technological life support systems. Nanotechnology capabilities continue advancing toward molecular-scale manufacturing that could enable construction and modification of materials at atomic levels, potentially allowing humans to create substances with precisely designed properties for specific applications such as space construction, environmental restoration, or biological enhancement. These technologies might eventually enable humans to modify planetary surface materials, atmospheric compositions, and even geological processes at scales that approach natural planetary engineering. Space-based solar power systems could provide clean energy sources that enable large-scale environmental modifications while supporting growing human populations without depleting Earth's natural resources or creating environmental pollution. Advanced energy technologies might eventually enable manipulation of planetary orbits, stellar energy output, or even cosmic-scale engineering projects that create optimal conditions for life and consciousness throughout star systems or galactic regions. Consciousness research and neurotechnology development suggest that humans may soon understand the mechanisms that generate awareness, creativity, and intelligence well enough to enhance these capabilities through biological modifications, technological interfaces, or hybrid systems that combine biological and artificial components. Brain-computer interfaces already enable direct mental control of external devices while providing new sensory capabilities that expand human perception beyond natural biological limitations. The convergence of genetic engineering, artificial intelligence, nanotechnology, and space technology creates possibilities for humans to engage in planetary design projects similar to those that may have shaped Earth's development throughout its history. Advanced human civilizations might eventually possess capabilities to create designed worlds, guide evolution toward consciousness, and establish life throughout the galaxy using principles similar to those that may have operated in Earth's development. Contemporary environmental challenges provide opportunities for humans to develop planetary management capabilities through necessity as much as curiosity. Climate change mitigation, ecosystem restoration, and sustainability technologies require systematic understanding and active management of planetary-scale processes that could provide experience and knowledge necessary for eventual terraforming and planetary engineering projects on cosmic scales. The ethical implications of becoming cosmic designers raise questions about humanity's responsibilities and purposes. If we develop capabilities to create life, design planets, and guide evolution throughout the galaxy, should human intervention in cosmic evolution follow the patterns that may have guided Earth's development, or should we develop alternative approaches based on human values and understanding of consciousness, creativity, and cosmic purpose? Some researchers propose that developing cosmic design capabilities represents humanity's intended evolutionary destiny, suggesting that Earth may have been designed specifically to create technological civilizations capable of continuing cosmic evolution and consciousness development throughout the universe. This perspective views human technology development as the natural outcome of successful planetary design rather than accidental achievement or potential threat to planetary systems. The acceleration of technological development suggests that humans may achieve cosmic engineering capabilities within centuries or millennia, rather than millions of years making current decisions about technology development, environmental management, and space. Exploration crucial for determining how humanity will use advanced capabilities if we successfully develop them. Current choices may establish precedents and principles that guide human cosmic activities for millions of years. Artificial life research demonstrates that humans are beginning to understand the fundamental principles that govern self-organization, evolution, and consciousness development in ways that could enable us to create digital ecosystems, virtual worlds, and computational environments where new forms of consciousness and intelligence can develop, according to design parameters, while maintaining autonomy and creative capabilities. The potential for humans to develop technologies that exceed the capabilities that may have designed Earth raises questions about whether we might eventually surpass our potential creators or join cosmic engineering communities that operate at galactic scales to create optimal conditions for consciousness development throughout the universe. Human technology development trajectories suggest possibilities for eventual participation in cosmic civilization networks that span multiple star systems. Philosophical and spiritual implications of becoming cosmic designers challenge human understanding of our relationship with creation, consciousness, and cosmic purpose. If humans develop capabilities to create worlds and guide evolution, do we become gods ourselves? Or do we fulfill roles that were always intended for consciousness that successfully evolves from designed worlds toward cosmic engineering capabilities. The transition from being products of possible cosmic design to becoming cosmic designers ourselves may represent a crucial phase in consciousness evolution where successful technological civilizations either develop wisely and join galactic engineering communities or fail to manage their capabilities appropriately and destroy themselves or their environments before achieving cosmic citizenship and constructive participation in universal consciousness development. Current human activities in genetic engineering, artificial intelligence, space exploration, and environmental management may represent training exercises or testing phases that determine whether humanity possesses the wisdom, ethics, and long-term thinking necessary to safely develop and responsibly use cosmic engineering capabilities that could affect consciousness development throughout the galaxy and potentially throughout the universe. Whether humans successfully become cosmic designers ourselves may depend on learning from the apparent design principles that created Earth as a platform for consciousness development, while developing our own approaches to planetary engineering, life creation, and consciousness enhancement that serve cosmic evolution toward greater awareness, creativity, and appreciation of universal beauty and complexity. Hundreds of light years away, the Kepler Space Telescope discovered Kepler 452b, a planet orbiting within its star as habitable zone at a distance that could maintain liquid water on its surface. The planet receives similar energy levels to Earth from a sun-like star, completes its orbit in 385 Earth days, and appears to possess atmospheric conditions that might support complex chemistry and potentially life. This discovery represents one of thousands of exoplanets found orbiting other stars, raising profound questions about whether Earth as apparent design represents a unique cosmic accident or evidence of systematic planetary engineering throughout the galaxy. The search for potentially habitable exoplanets reveals that worlds capable of supporting life may be far rarer than initially expected when statistical models suggested that billions of Earth-like planets should exist throughout the Milky Way galaxy alone. Most discovered exoplanets orbit too close or too distant from their stars to maintain liquid water, possess atmospheric compositions incompatible with complex chemistry, or experience extreme climate variations that would prevent stable environmental conditions necessary for evolution toward consciousness. Red dwarf stars, which comprise approximately 75% of all stars in our galaxy, present particular challenges for habitability despite their long lifespans and stable energy output. Planets in the habitable zones of red dwarf stars would likely become tidally locked, with permanent day and night sides that create extreme temperature differences, violent atmospheric circulation, and potentially lethal radiation exposure during stellar flares that could strip away protective atmospheres and sterilize planetary surfaces. The rare Earth hypothesis proposes that complex life requires such a precise combination of planetary, stellar, and galactic conditions that technological civilizations may be extraordinarily uncommon throughout the universe. According to this model, Earth's habitability results from an improbable convergence of factors, including optimal stellar type and stability, planetary size and composition, moon presence for tidal and rotational stabilization, magnetic field protection, plate tectonics, and galactic location away from high radiation regions. TRAPPIST-1, a red dwarf star system containing 7 Earth-sized planets in close orbits, demonstrates both the possibilities and limitations of alternative planetary arrangements. Several planets orbit within potentially habitable distances from their star, yet they likely experience tidal locking, atmospheric stripping, and radiation levels that challenge the development of stable climates suitable for complex life evolution. The system illustrates how planets can be numerous, yet still fail to meet the precise requirements for habitability. The atmospheric compositions of discovered exoplanets rarely match the narrow ranges of gases required for complex life and technological civilization development. Many planets possess thick carbon dioxide atmospheres, They create runaway greenhouse effects, while others have lost their atmospheres entirely through stellar radiation or insufficient gravitational retention. The precise balance of gases that maintains Earth as climate stability appears to be exceptionally rare among known planetary systems. Stellar evolution timelines create additional constraints on habitability that limit the time available for consciousness to develop on most exoplanets. Massive stars burn through their fuel quickly and end their lives in explosive events that would sterilize nearby planets, while smaller stars may not provide sufficient energy for complex chemistry to develop rapidly enough before other factors destabilize planetary conditions. The Sun's characteristics as a G-type star provide optimal energy output and lifetime for consciousness evolution. The galactic habitable zone concept suggests that planetary systems require specific locations within galaxies to maintain long-term stability and safety from high-energy phenomena. Too close to galactic centers, and radiation from black holes, neutron stars, and frequent supernova would prevent complex life from developing. Too far from galactic cores, and insufficient heavy elements would be available for rocky planet formation and complex chemistry necessary for biological evolution. Gravitational interactions in multi-planet systems often create orbital instabilities that prevent long-term habitability, even when individual planets might otherwise support life. Computer simulations reveal that most planetary systems experience gravitational perturbations that alter planetary orbits over millions of years, potentially moving habitable worlds outside their stars' habitable zones or creating eccentric orbits with extreme climate variations incompatible with complex life. The frequency of potentially life-supporting planets around Sun-like stars appears much lower than early estimates suggested, with current observations indicating that Earth-sized planets in habitable zones around stable long-lived stars may occur in less than 1% of stellar systems. This rarity suggests either that technological civilizations are extraordinarily uncommon throughout the galaxy, or that habitable planets require systematic engineering rather than natural formation processes. Alternative habitability models propose that life might develop under conditions very different from Earth's environment, potentially in subsurface oceans on moons like Europa and Enceladus, in dense atmospheres of planets like Titan, or through exotic chemistry based on different elements and energy sources. These possibilities could dramatically increase the number of potentially habitable worlds, yet they might also indicate that consciousness development requires Earth-like conditions, even if simple life can exist elsewhere. The Fermi paradox highlights the apparent contradiction between statistical predictions that suggest intelligent life should be common throughout the galaxy and the observable absence of evidence for extraterrestrial technological civilizations. If habitable planets are numerous and evolution toward intelligence is probable, then radio signals, space engineering projects, or other evidence of galactic civilizations should be detectable through contemporary astronomical observations and space exploration activities. Some researchers propose that the absence of detected extraterrestrial civilizations indicates either that technological development is extremely rare, that advanced civilizations actively avoid detection, or that they engage in activities beyond current human understanding or recognition. Alternative explanations suggest that consciousness development requires such precise conditions that Earth may represent one of very few successful planetary design experiments within our galactic region. The possibility that habitable planets require systematic engineering rather than natural formation processes would resolve the Fermi paradox by suggesting that technological civilizations are products of deliberate cosmic projects rather than random evolutionary outcomes. If advanced civilizations create designed worlds like Earth to develop consciousness and intelligence, then the rarity of detectable extraterrestrial activity might reflect the intentional isolation of developing civilizations until they achieve specific technological and ethical milestones. Astrobiology research continues searching for biosignatures in exoplanet atmospheres that might indicate biological processes, while also developing criteria for recognizing technosignatures that would reveal the presence of technological civilizations. These searches may eventually determine whether life and intelligence are common throughout the galaxy but difficult to detect, or whether Earth represents an unusual achievement that demonstrates the rarity and precision required for consciousness development. The implications of exoplanet research for understanding Earth's design depend significantly on whether other truly habitable worlds exist throughout the galaxy and whether any of them have developed technological civilizations. If Earth proves to be unique or extremely rare, this rarity might support arguments for intentional design rather than cosmic accident. If habitable worlds are common, but consciousness is rare, this pattern might indicate that planetary engineering alone is insufficient without additional guidance or intervention. Future space telescopes and interstellar exploration missions may eventually provide direct evidence about the frequency of habitable worlds, the presence of life on other planets, and the existence of technological civilizations throughout the galaxy. These discoveries could either support Earth's uniqueness as evidence of special design, or reveal that consciousness development represents a common outcome of cosmic evolution processes that operate throughout the universe to create optimal conditions for awareness and intelligence. Whether the mirror of the stars reflects Earth as a unique cosmic masterpiece or as one example of systematic consciousness development throughout the galaxy may determine how humanity understands its role and responsibilities as potentially the first technological civilization to recognize the apparent design of its home world and develop capabilities to continue cosmic engineering projects that create optimal conditions for consciousness evolution throughout the universe. Deep within Earth's crust, seismic monitoring stations detect rhythmic patterns of micro-earthquakes and ground movements that seem to follow cycles unrelated to tectonic stress, solar influences, or gravitational forces. These mysterious vibrations pulse through the planet like a slow heartbeat, creating electromagnetic signals and infrasonic frequencies that propagate through both solid rock and atmospheric layers and patterns that some researchers interpret as potential communication attempts or manifestations of planetary consciousness. The Taos hum in New Mexico represents one of hundreds of similar phenomena reported worldwide, persistent low-frequency sounds that affect sensitive individuals in specific geographical locations while remaining undetectable through conventional acoustic instruments. These mysterious auditory experiences occur at frequencies that correspond to natural electromagnetic phenomena, yet they appear to carry information patterns or modulated characteristics that suggest purposeful transmission rather than random natural noise. Aurora displays demonstrate Earth's electromagnetic field interacting with solar wind particles to create spectacular light shows that sometimes exhibit organized patterns, geometric forms, and coordinated movements across vast distances that seem too systematic for random electromagnetic interactions. Some observers report aurora configurations that appear to respond to human attention or consciousness, displaying increased activity or altered patterns when groups of people focus mental attention on the phenomena. Electromagnetic anomalies at sacred sites worldwide create measurable field variations that correlate with geological features, astronomical alignments, and biological effects on visitors who report enhanced consciousness states, healing experiences, and intuitive insights during exposure to these energy phenomena. The precision and stability of these electromagnetic patterns suggest either unknown geological processes or purposeful engineering of planetary energy systems. Crop circle formations appear overnight with geometric precision that requires mathematical knowledge and construction capabilities exceeding what hoaxers could achieve within available time constraints, while also creating measurable electromagnetic effects. Cellular changes in affected plants and consciousness-altering experiences in visitors that suggest interaction with intelligent forces rather than human artistic expression alone. The information content and mathematical sophistication of complex crop formations continue, challenging conventional explanations. Ball lightning and other atmospheric plasma phenomena demonstrate organized behavior that appears to involve information processing, purposeful movement, and interaction with human consciousness in ways that suggest intelligence rather than random electrical discharge. Witnesses report that these luminous objects seem to observe human activities, respond to mental commands, and communicate information through color changes, movement patterns, and electromagnetic effects. Underground water systems create acoustic resonances and electromagnetic patterns that generate measurable effects on human consciousness and biological processes, while also producing mysterious sounds, lights, and energy phenomena that correlate with geological features and astronomical cycles. Some researchers propose that aquifer systems function as planetary communication networks that transmit information through hydrological and electromagnetic processes. Ocean bioluminescence displays sometimes create organized patterns of light that span hundreds of miles while demonstrating coordinated timing and geometric arrangements that suggest communication between marine organisms or interaction with planetary electromagnetic systems. The scale and precision of these biological light shows exceed what conventional marine biology attributes to simple biological responses to environmental stimuli. Geomagnetic field variations create atmospheric ionization effects that influence radio propagation, satellite communications, and biological systems in ways that sometimes appear to carry information patterns or respond to human technological activities and consciousness states. The correlation between magnetic field variations and human psychological or spiritual experiences suggests possible planetary feedback systems that interact with consciousness. Mysterious radio signals detected by astronomical instruments sometimes originate from Earth's surface or atmosphere rather than cosmic sources, displaying characteristics that suggest technological rather than natural origins while remaining unidentifiable through conventional electromagnetic monitoring and analysis. These signals often occur at frequencies and with modulation patterns that appear designed for long-distance communication or information transmission. Atmospheric ionization events create luminous phenomena such as earthquake, lights, mountain peak glows, and mysterious aerial illuminations that demonstrate organized behavior, geometric patterns, and apparent responsiveness to human observation that challenge conventional understanding of atmospheric physics and electrical discharge processes. The timing and characteristics of these events suggest possible connections with consciousness or intelligence. Subsurface gas emissions from geological formations sometimes produce acoustic effects, electromagnetic disturbances, and atmospheric anomalies that create communication-like patterns of sound, light, and energy that appear to carry information or respond to environmental changes in ways that suggest purposeful transmission rather than random geological outgassing processes. Gravitational anomalies detected through sensitive instruments reveal variations in Earth's gravitational field that follow patterns unrelated to known mass distributions, tidal forces, or geological structures, suggesting either unknown physical processes or systematic modulation of gravitational effects through mechanisms that contemporary physics cannot explain adequately. Some researchers propose that Earth possesses distributed intelligence that emerges from the interaction of geological, biological, and electromagnetic systems operating at planetary scales to create information processing capabilities that enable the planet to monitor its own condition, respond to environmental changes, and potentially communicate with conscious beings who develop sufficient sensitivity to detect and interpret planetary signals. Synchronicity phenomena reported by individuals who develop heightened environmental sensitivity suggest that Earth's communication attempts might operate through orchestrated, meaningful coincidences, symbolic events, and consciousness experiences that provide information and guidance to humans who learn to recognize and interpret these subtle communication channels rather than conventional electromagnetic or acoustic signaling. The increasing frequency and sophistication of reported anomalous phenomena during the contemporary period of environmental crisis and technological development might indicate that Earth, as communication efforts, are intensifying in response to planetary stress or human civilization, as approach to technological capabilities that could either support or threaten planetary habitability and consciousness development. Indigenous wisdom traditions worldwide describe Earth as a conscious being that communicates with humans through natural phenomena, dreams, visions, and environmental signs that provide guidance for living in harmony with planetary systems while fulfilling human spiritual and evolutionary purposes. These traditional knowledge systems offer frameworks for understanding and interpreting planetary communication that modern science has largely ignored or dismissed. Contemporary environmental monitoring instruments occasionally detect patterns in atmospheric, oceanic, and geological data that appear to contain information structures or communication attempts that remain unrecognized because scientific analysis focuses on measuring physical parameters rather than searching for intelligence or communication within natural phenomena. The development of new analytical approaches might reveal communication patterns that exist within conventional environmental data. Whether Earth's apparent communication attempts represent emergent planetary intelligence, distributed consciousness arising from complex system interactions or responses programmed into planetary systems by cosmic designers. The accumulating evidence suggests that our world possesses capabilities for information processing and communication that extend far beyond what conventional science attributes to geological and biological processes operating through purely physical mechanisms. The possibility that Earth actively communicates with its inhabitants raises profound questions about humanity as relationship with our planetary home and our responsibilities as conscious beings who might serve as Earth as partners in managing planetary systems while fulfilling cosmic purposes that extend beyond human survival and technological development to include planetary consciousness, evolution, and cosmic communication activities. Standing at the boundary between known and unknown, contemporary science reveals the remarkable precision required for Earth-sea habitability while simultaneously acknowledging vast gaps in understanding how such precision could arise through random processes alone. Every new discovery about planetary formation, stellar evolution, atmospheric chemistry, and biological complexity adds layers to the mystery rather than resolving questions about whether Earth represents cosmic accident or intentional design. Quantum mechanics suggests that consciousness and observation play fundamental roles in determining physical reality at the smallest scales. Yet science lacks adequate theories to explain how quantum effects might scale up to influence planetary formation, biological evolution, or cosmic structure. The possibility that consciousness participates in creating the physical universe raises profound questions about whether Earth as apparent design reflects the universe becoming aware of itself through evolved observers. Dark matter and dark energy comprise approximately 95% of the universe's mass energy content, yet their properties and interactions remain largely unknown despite decades of research using the most advanced scientific instruments ever created. These invisible components of reality might operate according to principles that could explain fine-tuning, consciousness, and apparent design throughout the cosmos without requiring supernatural intervention. The information paradox in physics highlights fundamental gaps in understanding how information is processed, stored, and transmitted throughout physical reality, from quantum scales to cosmic structures. If information represents a more fundamental aspect of reality than matter and energy, then Earth as apparent design might reflect information processing and communication systems operating at planetary scales through mechanisms that transcend current scientific understanding. Consciousness remains scientifically unexplained despite advances in neuroscience, psychology, and cognitive research that map neural correlates of awareness without explaining how subjective experience emerges from objective physical processes. The hard problem of consciousness suggests that awareness might represent a fundamental feature of reality rather than an emergent property of complex chemistry, implying that Earth's apparent optimization for consciousness development might reflect cosmic principles rather than biological accident. The anthropic principle in cosmology recognizes that universal physical constants appear fine-tuned for the existence of observers, yet mainstream science attributes this apparent design to either selection bias or undetectable parallel universes rather than considering intentional calibration of cosmic parameters. Alternative approaches suggest that universal fine-tuning might reflect systematic optimization by cosmic intelligence or natural selection processes operating on universal scales. Complexity theory reveals how simple rules and initial conditions can generate sophisticated patterns and organized structures throughout natural systems. Yet science cannot predict which initial conditions will produce complexity versus chaos, or explain why the universe appears biased toward increasing organization and information processing capabilities rather than maximum entropy and randomness. The emergence of life from non-living chemistry represents a transition that science can describe but not fully explain, particularly regarding the origin of genetic information systems, cellular organization, and metabolic coordination that enable living systems to maintain organization while increasing complexity through evolution. The gap between chemistry and biology might indicate missing principles or external influences that guide matter toward organization and information processing. Evolution explains biological adaptation and diversification through natural selection, operating on random mutations, yet the rapid appearance of complex innovations in the fossil record, the precision of molecular machinery within cells, and the emergence of consciousness challenge gradualistic explanations and suggest either missing evolutionary mechanisms or external influences that guide biological development toward specific outcomes. The Fermi paradox highlights the contradiction between statistical predictions suggesting that intelligent life should be common throughout the galaxy and the absence of detectable evidence for extraterrestrial technological civilizations. This paradox might indicate that consciousness development is extremely rare, that advanced civilizations actively avoid detection, or that Earth represents a unique or deliberately isolated planetary system. Anomalous phenomena reported throughout history and continuing in contemporary times suggest either unknown natural processes or interactions with intelligence that operates through mechanisms beyond current scientific understanding. The consistency and global distribution of reports describing similar anomalous experiences across different cultures and time periods challenge conventional scientific assumptions about the completeness of current knowledge. Environmental tipping points and feedback loops in Earth, as climate and ecological systems demonstrate, the planet's exquisite sensitivity to small changes, revealing how precisely balanced conditions must be maintained for continued habitability. The complexity of interactions between atmospheric, oceanic, biological, and geological systems suggests either remarkable coincidence or systematic engineering that maintains optimal conditions for life. The acceleration of scientific discovery and technological development during the past few centuries might indicate either natural intellectual evolution or systematic revelation of knowledge that becomes accessible to consciousness when it reaches specific developmental stages. The timing of major scientific breakthroughs and technological innovations sometimes appears coordinated in ways that suggest external guidance rather than random human achievement. Interdisciplinary research increasingly reveals connections and patterns that span traditional academic boundaries, suggesting that reality operates as an integrated system where consciousness, biology, chemistry, physics, and cosmology influence each other through mechanisms that reductionist scientific approaches cannot adequately address. Holistic understanding might require new scientific paradigms that recognize consciousness as a fundamental feature of reality. The possibility that Earth represents a designed world created by cosmic intelligence poses challenges for scientific materialism that assumes consciousness emerges from matter rather than vice versa. If consciousness precedes and shapes physical reality rather than emerging from it, then Earth as apparent design might reflect intentional creation by cosmic consciousness rather than accidental formation through random processes. Some researchers propose that science approaches a phased transition where accumulating evidence of fine-tuning consciousness primacy and systematic organization throughout natural systems requires new theoretical frameworks that integrate intelligence and intentionality as fundamental features of reality rather than emergent properties of complex matter. This paradigm shift might revolutionize understanding of Earth's apparent design and humanity's cosmic role. The convergence of scientific evidence from cosmology, physics, biology, and consciousness research toward recognition of systematic organization and apparent purpose throughout reality suggests either that the universe is far more mysterious than current scientific paradigms acknowledge, or that science is discovering evidence of intelligence and design that operates according to principles beyond current theoretical understanding. Contemporary environmental and technological challenges might represent crucial tests of whether human consciousness and scientific understanding develop rapidly enough to comprehend and appropriately respond to Earth's apparent design and humanity's potential role as conscious participants in cosmic evolution rather than accidental products of random natural processes. The edge of knowledge reveals both the remarkable sophistication of scientific understanding about Earth's systems and the vast territories of mystery that remain unexplored, suggesting that ultimate answers about Earth's design and humanity's cosmic purpose might require integration of scientific investigation with consciousness exploration and recognition of intelligence, operating at scales and through mechanisms that transcend current scientific assumptions about the nature of reality. Whether science eventually explains Earth as apparent design through natural processes or discovers evidence of cosmic intelligence and intentional creation, the journey toward understanding continues expanding human consciousness and appreciation of the magnificent complexity and beauty that characterizes our planetary home and cosmic environment. The night sky stretches endless above. Stars glimmer like cold embers scattered across velvet darkness. Beneath them, Earth turns quietly, oceans breathing, forests whispering, mountains standing in stillness. It is here, in this fragile balance of shadow and light, that the final question lingers. What if Earth was designed? Some see only randomness. They see collisions of dust and gas pulled together by gravity. They see billions of years of accidents and chance alignments. To them, Earth is one lucky world among countless others, its conditions improbable, yet inevitable in the vast lottery of space. But for others, the evidence feels too precise. The tilt of Earth's axis, the moon's improbable orbit, the exact mixture of gases in the atmosphere, the presence of liquid water rare, precious, yet covering most of the surface. Each element appears tuned, as though the planet was crafted, not merely formed. Throughout history, cultures have whispered this same suspicion. Ancient myths spoke of creators, architects, and builders of the world. The Egyptians told of Ptah, who shaped creation with thought and word. The Greeks imagined Prometheus, molding mankind from clay, gifting fire to spark civilization. In India, the celestial craftsman Vishwakarma built the very heavens. In every corner of the world, the idea echoes that Earth itself may have been a deliberate design. Modern science rarely entertains such notions. Yet even within its boundaries, questions remain. Why does water behave so strangely, expanding when frozen, defying the rules of most matter? Why is Earth's iron core still molten, driving a magnetic shield that deflects deadly radiation? Why is our sun so stable, its light unwavering across the span of human memory? These are curiosities often explained as coincidence. But coincidence upon coincidence begins to resemble intention. Meanwhile, whispers from the past remind us of something more. The Maya aligned temples to the stars with unerring precision. The builders of Stonehenge charted celestial movements with megaliths that still stand. The pyramids of Giza mirror the stars of Orion's belt. Were these merely acts of devotion, or remnants of an ancient knowledge that the earth and sky themselves were laid out according to a greater design? Odd facts linger like footprints in the sand. The moon, almost exactly 400 times smaller than the sun, rests 400 times closer, making perfect eclipses possible. A ratio of staggering neatness, seen nowhere else in the solar system. The Earth's day, slowly lengthening across eons, stabilizes around 24 hours, an ideal rhythm for the human body. And the planet's magnetic poles wander, reversing in cycles, as though following a hidden script written into stone and field. Some propose the Gaia hypothesis that Earth behaves like a living organism, regulating itself to sustain balance. When the planet warms, clouds thicken, reflecting heat. When carbon rises, forests bloom, drawing it back into the soil. It is as if Earth breathes, heals, and maintains its own fragile homeostasis. If Gaia is not merely metaphor but mechanism, then perhaps the planet is more than rock and ocean. Perhaps it is alive in ways we cannot yet measure. And still deeper mysteries persist. Consciousness itself born from the clay of Earth, the neurons of the brain, the sparks of thought defies explanation. Did the planet intend for awareness to bloom within it? Or is consciousness the ultimate accident, an echo of design hidden within biology? Imagine for a moment that life was not inevitable, but invited. That Earth was seeded, sculpted, or tuned like an instrument. The oceans became wombs of creation. The continents became stages for civilizations. The skies became maps of eternity. And through it all, the question remained, who or what was the designer? Some point outward. They imagine civilizations older than time, architects among the stars who shape worlds as easily as humans shape clay. Perhaps they left Earth in orbit, a living experiment spinning silently through the void. Others turn inward. They see divinity woven into every cell, every star, every grain of sand. For them, design is not external, but eternal, embedded in the fabric of existence itself. But what if the truth is stranger still? What if there was no singular designer, but a process of design itself? Not a god, not aliens, not chance alone, but a universe that experiments, learns, and creates over billions of years. A cosmos where Earth is both accident and artifact. Randomness guided, chaos sculpted, patterns repeating until beauty emerges. In this view, Earth is a tapestry. Each thread geology, biology, atmosphere, consciousness, woven together, not by a hand, but by the very nature of reality. A design with no designer, yet a design all the same. And so the question circles back. Was Earth planned? Or is planning itself an illusion, born of minds seeking meaning in endless complexity? Perhaps design is simply perspective. To one observer, a random collection of numbers. To another, a perfect equation. To one, coincidence. To another, destiny. The camera drifts outward now. The planet spins slowly, a fragile sphere of blue and green against the darkness of space. Storms curl across oceans like brushstrokes. Rivers glitter like threads of silver. Continents rise like ancient bones, carved by time. From above, Earth itself appears as a single work of art, too beautiful, too improbable, too alive to be dismissed as accident. Yet the mystery endures. For in the end, no theory closes the circle. Science reveals structure, but not purpose. Myth offers stories, but not proof. Speculation ignites wonder, but not certainty. The truth may lie forever beyond reach, shimmering just out of sight, like starlight on water. And so the question remains, unresolved. What if Earth was designed? Perhaps the answer is not in solving the mystery, but in carrying it. Perhaps awe itself is the gift, the awareness that life exists, fragile and fleeting, upon this unlikely world. That we breathe and dream and wonder, suspended in a universe of questions. The music softens, the voice fades. Only silence lingers, carrying the weight of the unknown. If this journey stirred something within, consider subscribing and join again, for the next mystery still waits, hidden in the shadows of history and the stars above.